All right, it's already 2, so now we are gonna start the webinar. So good morning, good afternoon to everyone. It's a pleasure to meet you, and I thank you to everyone that is joining us. So today we're gonna have this amazing webinar that is about the construction materials, and this is gonna be the 9th International Webinar of Construction Materials. I would thank you to everyone for your time to joining us and to share all the information that we're gonna see today that is gonna be very helpful for everyone. And the purpose of this webinar is to share all the knowledge on construction and mining materials. Also, another important thing that we're going to do today is to connect academia and industry, creating meaningful connections and be forming across disciplines and geographical boundaries. And also, we're going to have some time to discuss about innovation, safety, and sustainability in all the chats in questions. So today's topic, we are going to see materials handling system, risk management in construction and mining projects. Also, we are going to see optimization in construction and environmental conservation. So today we have 9 amazing speakers that they are going to delight with all the information. The first one is going to be Matthew Stevens. Then we're going to have Hala Younis, Farid Sartipi, Tahera, Hammond, Maureen Isu, Kwawdwo, and Timothy, Franklin, and Isaac. So this is going to be the agenda for today. We're going to be around 2 p.m. to 5:25 p.m. Maybe it's going to be a bit shorter. Every speaker is going to have 15 minutes to speak. Then we're going to have like 5 minutes to finish the idea and to reply some questions. So in the opening, it's going to be Matthew Stevens, the first one, with applying chaos theory to a construction project to consistently better outcomes. And then it's going to be Hala Younis with effective and economical CFRP reinforcement. And then it's going to be Farid, Tahera, and Maureen, and Tahu. Then it's going to be Isaac, Franklin, and Timothy. And at the end, we're going to have like the closing and general question if everyone has something else to add. So just to make sure how it's going to work this, we are going to use in the 5 minutes for the question, just the chat. So everyone can ask something and then the speaker is going to reply. Then after that, well, every speaker is going to present in the computer too. So when they have the time, they're going to share the screen. And for the participants that are seeking continuing professional development recognition, certificates for attendance will be issued following the webinar in accordance with the statement requirement. So yeah, now it's gonna start Martha Steve. Thank you so much. I will stop share, so Matt, you can start. Matt, we can't hear you.
I believe, Matt, you are on mute.
Yes, and can you hear me now?
Yeah, now it's
Thank
working.
you.
Right, and you're seeing chaos theory as the opening slide, correct?
Yes.
Okay, thank you very much. Thanks for having me, everyone. I do appreciate the invitation. This area is going to be a bit leading edge. We have 2 projects going on with UNSW. I am at Western Sydney, and so I'll tell you some interesting things. Hopefully, you'll find this to be helpful. But really, in chaos theory, we're learning how to increase construction productivity, which is the input-output or the efficiency. Of course, the production, if you're from Australia, is the 100,000, the 2.1 million homes that we're seeking to build. So both are very good for the industry. Here's a little bit about myself. I've been around since in the industry since '74. You can do the math. That's a while. I still actively healthy and all these things. So I just continue to hopefully have one more insight, about things that you would learn from. We're talking about chaos theory, which is obviously the reverse of order. And so what we're doing is we're trying to explain disorder and its cause and effect as a general idea. It's first applied in the natural systems. It was actually from a meteorologist talking about the butterfly wings in South Australia and the tornado in Texas. But we've applied it to human-centric systems. What's interesting is only 3 Q1 journals have been written about chaos theory in construction, which I find an opportunity for me and for others. And so this is what we're going to talk about today. To make it clear, natural systems are bounded. They're limited. We've had 13 billion years of experience through the universe. We've had a few less years in Earth, but things have been comparatively predictable and bounded or safe. Human-centric systems, as we know, are very unpredictable. In fact, we don't know what people are capable of sometimes. And so in construction, what we're looking for is really this ricochet effect as an indicator of that. So one bad thing goes wrong, all of a sudden affects 3 or 4 things down the line as we're trying to construct something. Construction is a chaotic system due to its many uncontrollable factors. If you look at the weather, very uncontrollable by anyone. Information availability, if you're the person seeking the information, stakeholder actions, and then the last thing really is the many functions that are in a project, because it's the design of the project, the cost estimating of the project operations of building it, financial management, human resources, are disparate and not unified. We'll get to that point in just a minute. So order versus chaos is what we're looking for. Our assertion is one is desired in all things except research. And so in the material science areas, we have obviously many examples of research gone wrong, but actually gone right because we discovered something new through an accident, through a chaotic circumstance. All other things, we want order. We want things that go as planned. So we have this edge of order and emergence of chaos, which again in science and revolutions and in research, very important that we're on that edge. But in a for-profit business, not a good idea. It's obviously going to put in jeopardy your profit for that project profit for the year, and really, your reputation, all the things that go into a continuing future. So as an instruction, we want to use a graphic or two here only to instruct and give you a good picture, a good working model. And so in construction, it's not known very well, but if you look at the median return on investment of construction firms, the top half, as ranked by the banking data, are 3 times better than the bottom half. So you have this really large difference between companies with little chaos or no chaos or well-ordered systems and those that don't have a well-ordered system and have lower performance. Now, the reason that we bring this up is because we assert that the financial result is a proxy for strategic and operational decisions and execution. So said differently, if you're very disorganized, as you know, you're going to have lots of inefficiency, lots of cost waste, lots of schedule misses. But if you're very ordered and planned, then you're going to have more of that. And so we have this S curve, which is very prominent in construction. But what we say is that if you're very well planned and ordered, you're going to come out on an emergency efficiency zone, which means better than planned. And of course, the chaos zone, which we see a lot on the front page of the newspaper. Everybody thinks construction is chaotic because they see it or they witness it across the street. But the better contractors aren't top of mind because they're not on the front page and things are fine. And the bottom ones obviously are. So we got to get characterized by that, very ugly project that we witnessed again across town and in the newspaper or in the media. Okay, so the beginning state, of course, as we said, between the butterfly wings in South Australia and the tornado in Texas is the beginning state, what's starting the chaos. And so there's very small variations from planned to execution. So we wanted to start on this date. We start later. We wanted these people to be staffing the site. They're not there totally. And so we have these, really four major areas that cause this chaos in the construction project. Stakeholders' timely execution. Again, they're doing what they're contracted to do and at the right time, right place on the job. Information not collected or confirmed because it is a project. It is unique. And so we have to put an emphasis on information gathering. Cannot assume that's the same one as the last project. Otherwise, it's a manufacturing business. Projects are different. They're different in some ways or in many ways. Malaise, right? We have we're kind of busy and we're distracted, and other people are just not very conscientious. And we have this malaise and this active contribution collaboration as we try to learn about the project more and more earlier and earlier. So that malaise obviously causes some delays and some problems. You're finding a little bit of that. If I can pick on the Olympic project up in Queensland, they're in stoppage, right? They're in delay, and delay is a manifestation of chaos. They don't know what to do next, or they haven't planned for that next step. Not to criticize them, but you can see where that makes sense. And the last thing is stakeholder selfish or competitive focus. We might call that capitalism. We might call that other things, but people just doing what's good for them and not doing good for the project. So the beginning state is affected by these four. There's probably three or more you could add. Anything that's measured has to have a standard. So differently, if we have a certain professional standard and people meet that professional standard and exceed it, then we have a very good industry, right? And then if we have a lot of folks that are not doing it, then we have a very poor industry, and hopefully everybody's meeting the standard. Well, the standard for us, and this is through some research last year, is that we really know what each individual task in a project should be following. So let's say in a project, you might have 100 tasks between the roofer, plumber, concreter, builder. We have these tasks that we have to do. And let's say there's 100 of them, all very different. The first thing you need to do is information collect and confirm. Can't assume things. We know that causes chaos when you assume. If you don't collect it, you don't know, you guess. The next thing to do is collaboratively plan after you get the information. You can't plan while you get the information, because then you'll assume things and make plans, and later information will come in and cause a problem. Logistical support is the arrangement for material to arrive, for equipment to be staffed or offloaded on job, for the folks to be there on time, and then the quality and quantity that you want. Now, logistical support, obviously, as we return material all the way through the project and we have things going off rent, it goes throughout the project to the end, and that end point is important. The first thing you want to do, obviously, is have a test crew. You don't want to come out there with 30 people, but 3 people, and 3 people will go and go through the material, go through the location, see what's going on. And the reason for that is the plan is never perfect. Let me say that again. The plan is never perfect, even though we might have perfect planners. And so that test crew is a buffer against this assumption, problem, oversight, misunderstanding, or just somebody just fibbed to you. And so that they might be on the job for 3 days or a week or a day, but they really arrange things very, very well for the scaling up crew, which might be 27 more people, but they have these 3 people instruct them and show them. And all of a sudden we have this production that's very, very good, and hopefully productivity, because they're working efficiently and not, struggling with inexact arrangements. The replanning is important, very important, because we know the plan's not perfect. So this idea that we have to replan all the time. So a site manager or a project manager goes out there every half day and says, how can we make this easier? What's the problem? What do we assume that was wrong? And replan obviously has to happen if we're going to have any kind of productivity. We have to be aware and open to, we have to replan or ask the question and go from there. Now, the pink line is the measurement, and the measurement being important because as we measure, we know we're going well or not going well, we're deficient or we're not deficient, right? So we have to have measurement throughout. And I think that's important also in the fact that if you do this all at once, like some projects or some projects are forced into because they're behind, they do it all at once. They do the information collection confirmation with collaborative planning. It's all stacked up like pancakes. That your measurement can't help much because you don't have this individual measurement of information collection confirmation and all these things. And so that's all at once a violation of the standard, and certainly will come out in schedule adherence and cost. One of the interesting things about this model is, and this took a while, was the redeployment. People have been laid off an average of like 4 times if they're 30 years old in the construction workforce. That is people that work with their hands. And so when they see a project coming to an end or their work coming to an end, they'll slow down because they've been laid off through no fault of their own. They'll be laid off. We have the highest layoff rate of any industry. And so we have to have a redeployment plan. Are they going to this next job? Are we telling them something about, well, we'll do something special for you to have you, meet the time, but you have to have a redeployment plan. Don't forget, it's not only people, it's the equipment going back off rent 1 week earlier, not 1 week later. It's material that's extra, or maybe there's a claim against the freighter, things like that. But this standard, if it's repeated in every single task in a project, will be most efficient as long as it's laid out like this, not compressed. And in postmortem, obviously, you would find out if you did that real well. Now, in research, the way I understand it and the way I assert is that you have 2 transcendent goals. You have measurement, which helps you look at the past and learn from it. What is really the dynamic through the many, many projects over the many, many years, right? We really can learn through that if we take the time and look at all those projects and, again, make some assertions, kind of crystallize it or distill it. Looking to the future, if we do that, we can prevent. And so if you really get down to it, this is a little bit of a famous saying, but basically what we're saying is that you can, if you can predict the future, you're an expert. And that's true. It doesn't matter your credentials. It doesn't matter your body of work. It is the future. So we try to do that with this. Again, let's go through measurement first, then prediction later. There's macro factors that measure when measuring the past, right? So this is very general. So we have inputs that go into a project, like we just talked about, and then they're processed in a certain way, which is the P of A. And then the communication friction is very different because we have a human-enabled business. We have to have a communication variable. Why? Because people just don't transmit telepathically. They either communicate via email, voice, print, other ways. And then based on that, generally speaking, we have this metric, which can mean I'm ahead of schedule or I'm behind a schedule. So my metric being very, very good if it's lower, or if it's negative, very, very good, very, very bad if it's positive or high. So here's the equation. I don't want to spend some time on it due to our time together. But what you're really looking at, if you really want to get down to what's the value of this research, is predicting project chaos, because we can be proactive and we can prevent it. So there's 2 major inputs in a construction project. We have site operations, which obviously is where 90% of the cost is, 80% of the risk, right? 100% of the revenue. And then we have the office, which enables everything, right? And then the office always has to lead the site. If we don't have the contract signed, there's not much we can do. If we don't have the material order, there's not much we can do on the site, right? So we have this site, the office work has to be done before the site work. In most cases, if not all cases. I'm sure you have an exception. Okay, so to make it overly complicated, but you wanted to understand this. Obviously, I want you to understand this very well. Is that we have office functions, which are 6, and site functions, which are 6. And what we've done is we've weighted them. And notice that just take the edges, just take the first and the last, just to make it clear. Office, the information collection, confirmation, quality, and timeliness. We collect it early. We confirm it as true. It's foundational. It actually leads the way for planning. We can't plan accurately without that. And the last one is resource redeployment discipline, very unique to construction. We have temporary assets called equipment. We have permanent assets called material, which goes in the project. We have extra material typically. Those are very important to recognize their value. And then everything in between, which really follows some of what I just said with the standard, that Gantt chart. Okay, so the idea here is that we get to a point where we actually can see in active or real time chaos emerging, and we can prevent it. We can do things that keep it away. So in summary, really a couple things. One is that a system of systems is needed for construction project management. I don't apologize for that statement. We don't need a system. We need a system of systems. Why? Because design is different than cost estimating, than project operations, than the financial management, human resources. So differently, there is no software that unifies those 5, right? One's visual, one's numbers, human resources is something different totally. And so it's we have that. Now AI has the potential, and will do this, and make it a unified piece of software. It will take some work, and we're working on it a little bit. But that's the system of systems idea thinking. Tellingly, there's no specific lean construction methodology application for 3 of these, right? Design and project operations, if you're in lean construction, you know it's there. But they've ignored it, or we've ignored it as lean practitioners, let's say. So that's, again, an indication that we've got a real opportunity here for understanding this better and really reforming construction project management. So, okay, I'm just going to tell you what I said. Hopefully this makes sense. Chaos in construction projects not welcome, obviously. It affects the big 4 goals, right? Safety, quality, cost, schedule, right? Safety is very important, morally imperative. Quality, people remember you 30 years later because of that. Cost keeps you in business. Schedule, that's how a lot of people measure whether you're successful or not. You're on time. You take away resources from a company's portfolio project when you have chaos. So you're building 3 or 4 projects and you have this really problematic project. You don't want chaos because it takes resources away from the other 3, including the president's attention. So any chaos threatens the contractor's single-digit profit margin percentages. Now, the ROI is different, which is a different measure, but the single profit, it's really 5%. You want to use round numbers. And so this is very close to negative annual results, right? And so you want to really be vigilant and proactive against, again, preventing chaos. So the predictive equation that we propose is a starting point. It provides this prevention, which we think is extremely important. I think you'll agree. We're conducting 2 research projects this year with UNSW on this matter, both, and they're very promising. Lots of data. We have 2 captive contractors that are working with us that are very interested and enlightened. So, thank you for your time. Hope you enjoyed it.
Thank you so much, Matt. It was really interesting. Yeah. Guys, if you have another question, you can tell us on the chat. We would love to hear us.
Can I ask?
Of course.
Yeah.
How are you, Mr. Matt, Dr. Stevens?
Hey, Fred.
It's been a long time we haven't met. I came to university, had a chat with Alan Todd Hunter. We're looking for you. Unfortunately, you were not there, but to be able to see you once again. Been following your videos and other presentations as well, particularly last year about AI. And now mixing this presentation and your presentation last year on availability of data and also forming predictive models. Are data available vastly in any of those areas, such as human resources or financial perspectives, so that the machine learning algorithm will be fed with those data?
We have a starting point, which is a fully loaded project schedule, resource loaded. So it has, 3 people showing up for this week and, all these hours. And we can take that and we can certainly take projects that have gone well and projects that have not gone well. As far as the human resource piece, we have a project with 21,000 items, seriously. And it's all these, different things, but a lot of it's communication. And so we have to do a sediment index, which is the nature of the extraction. Was it confrontational, confirming? And so we judge that and can score that, again, through a standard index, which is called sediment today. There are other ways to do it. But this is, as you know, from the people over at UNSW and maybe from us, is that we're really trying to figure it out. I mean, we're not just doing a framework and that we're describing the world. We're trying to fix the world. We're saying, what are the things we got to watch out for? Now, one of the nice things about this is that we have this planned schedule, which means it doesn't have to be perfect, but it's planned. And if you can exceed that, you've done well. If you haven't exceeded that, you're in chaos or you've done poorly. But the data question, as you know, is the large elephant, a very large elephant in the room about why don't we have more data? We do have, but it takes, I have a relationship with one person for 5 years, the other person for about 2 years. And it takes that long to get that confidence, and they know what you know, and they want to do something. And that's very slow. I wish it was
just one thing interesting. How would that like, so we've got the data, the equation is also available, and we're
Yep.
expecting an outcome. How would that outcome be validated? Like, because we're getting data from past, and we are
Oh, that's a
expecting
good
that
question.
machine to
Yeah,
predict the future.
you've got an outcome called resource allocation, and you've got a thing called the schedule adherence. And if you're below that plan line, because the baseline schedule is the plan, right? If you don't meet the baseline schedule, you keep changing it and it's later and later and later, then all of a sudden you save at the end of the day, you know that's chaos. Even though you saved at the end of the day, you threw 30 people at it versus 3 people at it. But you have the data and you take those 3 factors. The communication friction is through the emails if you want to be scientific about it. So let's say we have all these emails and we say, boy, a lot of confrontation, a lot of changed decisions over 3 or 4 or 5 times. You've got evidence there's chaos there, right? And so then you can start doing a maturity thing, like these guys have worked together for 5 years, as a subcontractor builder. Oh, it's easier. Well, that's one of the factors, and it's a nuance. But yeah, you've got the 3 things I would look at seriously if you were going to start out, and we are, is the fully loaded baseline schedule with the resource allocation and the communication friction. And that would be the good starting point. Now, all the factors that you might put in communication friction about how they talked and the meeting length and the and 3 people miss meetings and they were never there. Yeah, that's all in that communication friction, just like it is the other.
Yeah.
You can you can get there. You can get there.
I appreciate it.
Yep. That's a good question.
You can talk. Yeah. Tell us your question.
Yes, thank you, Matt, for the presentation. My question would be, is it safe to say that a project would be in more chaotic state if the scope was under multiple changes or there was a scope creeping going on in a project that will increase our chaotic state? Will that be a relation or related to it? Will the percentage of the CPCM go higher?
Yeah, because you can see in the resource allocation, we have to plan it at the beginning of the design, and then we have these design changes, and then we have more architectural hours. I mean, people play all sorts of games with budgets, things like that, like in the federal procurement. You've heard the Willie Brown comment about the beginning budget is just a fishing expedition. Basically, we want to get people's interest, and then once we start and get going, then it's the public typically opts for putting more money toward it to finish the project, even though it's 25%, 80% over budget. But for your question is the planned versus the actual is the tell if there's chaos. Okay, so again, I use the example of the Olympics, which is not critical of them, but saying it's normal. When you have delays or stoppages in a project, that means there's chaos because they haven't planned for it, right? And the plan and the actual are not meeting each other. We're supposed to be working continuously for 3 years, and we stopped for 3 months in the middle of it. That's one of those things. So, but yeah, anything that's a change as a basic principle over the planned is going to be a signal of chaos.
My other question would be, out of your observations or your data collection, do you think it would be more chaotic for government-funded projects or private projects?
Oh, government-funded projects are typically on a very smooth stream. The bankruptcy rate of government project contractors, I don't know if you know this, but you take, out of 100% bankruptcies for 2025, 5.5% of them were government infrastructure project contractors because they have variation forgiveness and they have contractual tolerance, right? So you kind of, they do move the boundaries of the contract out a little bit. And again, we see it through the bankruptcy statistics. We're about 45% of the total construction spend, but we're 5% of the bankruptcies. Definitely incoherent.
Yeah. Thank you very much.
Thank you guys for the questions, and Matt, thank you so much. It was really interesting. So now we are going with Dr. Hala.
Thank you. Just want to share. Can you see my screen?
Not yet.
No. Okay. Well,
Yes.
oh, okay. Beautiful. All right. Beautiful. All right. Thank you, everyone. It's just yeah. All right. All right. Thank you, everyone. Good afternoon. Welcome to my presentation on identifying the effective reinforcement length for LVL timber structural beams using carbon fiber reinforcement polymer. I am Hala Younis, lecturer at Melbourne Polytechnic. Before starting, I would like to thank the Institute of Construction Materials for having me in this webinar and give me the opportunity to present a topic of my research study, completed research study. Now, before digging into my presentation, I would like to start with a general background. As we all know that the urban population is growing rapidly, and with such an increase, mid and large scale buildings offer a great solution for this rapid growth. However, the majority of those buildings are made of steel and concrete, which emit a huge amount of carbon. Now, we need to build those buildings using a sustainable, renewable material to lower the carbon emission. And a great example of this is timber. Timber is not only a low carbon material, it offers many advantages for future construction, as you can see in this figure. In terms of the environment, it is carbon storage, it is a renewable material, less generated construction and demolish waste. In terms of the community, it has a great impact on the community, not just for the people who are occupied the building, but also the internal community who are responsible to build the building, as they are dealing with the lightweight material. In terms of the economic, as you can see, it's faster construction, cost-effective transportation, lower lifting cost, easy to install. All these made the timber cost efficiency. Now, moving to this slide. So timber is not a new material. Timber has been a great source in construction industry since years ago. And as you can see in those figures here, so these historical buildings were built using timber, and they are still exist till today. From those historical buildings to the era of engineered wood products, timber now is widely used in large-scale infrastructure. And these are some examples of timber large-scale buildings. Engineered wood products are manufactured timber systems formed by bonding, layering, or laminating wood to improve strength properties and stability of the member. There are many types of engineered wood products used for different structural application. In this study, LVL structural beam was selected as it found it is commonly used in our construction industry. Now, as you can see in this graph, engineered wood products are being utilized in many large-scale buildings around the world. These buildings show that timber can now be used to construct taller and larger structures. And the numbers at the top of each bar written in red are the number of story levels for each one. However, the structural design systems used in those large-scale buildings are either hybrid system or double the quantity of the timber. These options unfortunately lower the sustainability and economical advantages of those buildings. So from this point, many studies have been conducted to reinforce timber structural members, utilizing, as you can see here in this figure, either the external strengthening or the internal strengthening. In this study, the approach of the external strengthening was adopted because it showed it is more practical approach. Now, for the reinforcement materials, the materials are either metallic materials or fiber reinforcement polymer composite materials. Now, according to the review study conducted in this research, it found that the composite materials offer many advantages. And as you can see here in this list, some examples of the key benefits of the composite materials as a reinforcement material in terms of the high strength to weight ratio, corrosion resistance, lightweight, easy to apply and install. So all these advantages help to make the decision on using those materials as a reinforcement material in this research study. Now, using the same reviewed study, it showed that the application of the reinforcement length is either to the entire length of the beam or to the entire length of the span or just part of the beam. So there are very limited studies that have investigated the effective reinforcement length required to achieve the maximum structural benefit. And here where my research light up. So my research focuses on estimating the effective and economical reinforcement length for LVL timber structural beams in order to lower the reinforcement cost and the use of unnecessary reinforcement materials. Now, to achieve this aim, these are the specific objectives were developed. Firstly, experimentally evaluate the effect of various lengths of carbon fiber reinforcement polymer on LVL beams. And secondly, estimate the effective reinforcement length. Now, to achieve those objectives, so this is the methodology followed in this research study, which was divided into 4 main phases. As you can see, the first phase was focused on the preparation of the material and equipment. Phase 2 related to the experimentation setup and arrangement. Phase 3 testing, and phase 4 was related to extracting the result. Now, this investigation was conducted physically and numerically using advanced finite element simulation techniques in Abacus software. Now, this slide shows the experimentation materials, starting with the 14 LVL timber beams. The total length of each beam is 2.1 meter. Reinforcement material, carbon fiber reinforcement sheet, and the various lengths are 300, 600, till 1800. Each time it increases by 300 millimeter. Adhesive products, as you can see in the last figures here, adhesive products are part A and part B, and the mixing ratio was 3:1. This is according to the manufacturer sheet. The figure on the right side here, as you can see, these are the 12 reinforced LVL beams with the various lengths of carbon fiber composite materials. Now, moving to the equipment and the setup. So this slide shows the loading machine at Latrobe University lab, where I conducted my research study. Also, it presents the 4-point bending arrangement to assess the behavior of the beams. Now, moving to the test arrangement. Test arrangement was divided into three groups. The first group, group 1, for unreinforced or control beams, and for the beams reinforced with the 300. Second groups for 600, 900, and 1200 reinforced beams. And the last group is for the 1500 and 1800 reinforced beams. Now, the reason for this this arrangement is just to facilitate the experimentation procedure. Now, after conducting the result, so this is the load deflection curves. So the load deflection curves for each beams was extracted, and the one presented in this figure is just the average of each reinforced category. Now, as you can see, carbon fiber reinforcement polymer sheet improves significantly the structural performance of the beam, and also delays significantly the fracture of each one. Now, these curves were further evaluated, and 3 strength properties were estimated, as you can see here. So these properties are fracture load, stiffness, and module of rupture. Now, the figures under each one are the result for each one. It shows the effect of the reinforcement length on each one and the improvement ratio for each one. The one written in red is the improvement ratio for each. Now, from the result, we can see that the effective reinforcement length is only 900 millimeters. So reinforcing the beam with only 45% instead of the entire beam or the entire span length. So only 45% for 2.1 total beam length will be required to have a good structural performance. Now, for the numerical study, so finite element modeling was conducted, as mentioned before, using Abacus. 3D finite element model was developed using those stages, started with the preparation, pre-simulation process, simulation process where we need to run the model for the analysis, and then post-simulation process. This is for extracting the result. Now, the first study was conducted for the 4-point bending model, developed using the same experiment setup and arrangement, and using the same geometrical properties of the timber structural beam. Now, the fracture load was estimated for each beam, and firstly validated against the experimental result. And as you can see, it showed a great agreement with the experiment result with only minimal error percentages. Now, using the same result, the effective reinforcement length was estimated, and again, it found that the effective reinforcement length is only 900. And the effective ratio is again 45%. Now, further analysis, further investigation was conducted here. This is the next study, uses the same model, but with a 3-point bending test and use a bit longer length of the beam. This time it's 2.4, as you can see in this table. Now, after conducting the parametric study here, this is the key result for the fracture load, and it found that the effective reinforcement length for this beam arrangement, it's ranging between 900 to 1200 millimeter carbon fiber, which means that the effective reinforcement ratio are ranging between 35% to maximum 50%. So from this point, those are the recommended studies. Study 1 focused on conducting an experimental investigation of different beam lengths using various carbon fiber reinforcement sheets between 300 to 1800 millimeter. Study 2 conduct an assessment of different beam cross sections this time using various carbon fiber sheets. And the third one is to conduct an evaluation of different sheet reinforcement configuration with varying reinforcement length. Thank you so much, and hope you enjoyed my presentation.
Thank you, Hala, for your presentation. It was really good. So anyone has a question for Hala?
Can I ask? Or maybe Omar
Yeah,
asks this time first. Sorry.
Yeah, sorry, Farid. Thank you, Hala, for the presentation. My question probably would be from a management perspective and cost relation. Do you know how much is the cost of reinforcing that timber? Was that part of your study?
No, it wasn't part, or wasn't part of the scope of my study.
So, yeah.
To evaluate the economical or the cost of the reinforcement. No, this is out of the scope.
All right.
The only economic comparative or study conducted in this research is just to compare the cost of LVL and glulam in order to finalize the selection of the structural member, and it found that LVL is more economical than glulam, so that's why it is adopted in this research. Further than this, no, wasn't part of this research study.
All right, yeah. I guess the reason why I'm asking this is just to have an idea of how much it will cost to increase the strength of these timbers by I think you mentioned 36%. That was for the fracture load, I believe that was. So now my last or my other question would be with concrete, we know that time will give concrete extra strength. It will get stronger with time. Using epoxy and strengthening timber, the way I'm not a structure engineer, so I wouldn't know. You would know this probably better. With a lot of mechanical failures with the epoxy, would time be something that maybe we should look into? Researchers should look into before commencing to such strengthening way?
Yeah, thank you, Omar, for this point. Well, this is a good question, and this has been discussed also before, and recommended to investigate these points experimentally. In this study, wasn't investigated or reviewed, but after conducting the experiment, this was recommended for future studies and research.
Okay, thank you. Thank you very much.
Thank you, Omar.
Thank you, Farid. Sorry, Farid. You can go.
No worries. Thank you so much, Dr. Younis, for a wonderful presentation. It's been a while that we haven't got any update from your recent projects. Just something very basic. What is LVL?
Laminated veneer lumber.
Okay.
It's a common type of engineered wood product used nowadays, in many construction projects.
And if I'm not mistaken, the purpose of this study was to increase the fracture threshold rather than limiting the deflection. Is that?
Now, the idea of this research is to estimate the effective reinforcement length. So the studies conducted for the reinforcement applied the reinforcement sheet or plate either to the entire length of the beam or the entire length of the span or just part of the beam. So there are very, very limited studies or investigation on identifying the effective reinforcement ratio to maximize the structural performance of the member.
There's no kind of data available on whether or not carbon reinforcement would limit the deflection.
Sorry, can you just say it again? Someone was.
The question was that there wasn't any kind of investigation on whether or not carbon fiber would limit the deflection of timber beams.
It will reduce the deflection. It's improved the structural performance of the member and the serviceability behavior, definitely. But the focus of this research is to identify the effective. Yes, there are.
If I go out and put 2 layers of fiber around timber, would it make it stronger or wouldn't it have any effects? Has it been studied?
Yeah, that's why this is another study. It's if you check study 3, it's recommended to conduct a further investigation on this, either to change the configuration of the reinforcement, adding more layers. But in this research is only 1 layer of U-shaped carbon fiber attached to the mid span of the beam. But for the future, it is, of course, recommended double the layers or different reinforcement configuration, different maybe fiber reinforcement polymer sheet type. So there are a lot, but it's very important to use the same various lengths in order to identify the factors. That's the.
Thank you so much. I appreciate it.
My pleasure. Thank you, Farid. Thank you, everyone.
Matt, do you have a question?
You are muted again.
Yeah.
I must have the old version of Zoom. Ma'am, let me just say real quickly, this is an encouraging note, is that I belong to a angel investment group where we invest in emerging ideas and technology, and I encourage you to think about manifesting this in a commercial idea. I know that might be something you're not planning on, but things like this have to be commercialized if we're going to have a real effect. We can talk later, send an email, do something over the next year, but there's a real need to kind of systematize this kind of thing where it's just dependable, structural and other qualities that we need. So I'll just leave it at that. There's no really question there. Just want you to think ahead a bit if you want to.
Yeah, definitely. Thank you so much. Thank you. Yeah. Thanks. Appreciate it. Thank you.
Thank you so much. So now we are going with Farid.
Okay. I have to share my screen, right? Can everybody see?
Charging. Yeah.
Okay,
Now we can see.
great. So, thanks everybody for joining. I personally learned a lot from the past two presentations, and hopefully this presentation will be also something for you to take away. During the past couple of months, I was involved in something called development of a polyurethane splice for conveyor belts. You may ask yourself that what does conveyor belt has to do with construction? It turns back to the offsite manufacturing. Any kind of offsite plant that you look at, there is a kind of conveyor involved. Whether you're looking at a concrete plant or a concrete precast plant, there is always a conveyor belt involved. And one of the key perspective is that whenever a conveyor belt normally fails, the production stops. So we were trying to find a repair kit made out of polyurethane that will be fast and easy to install on a conveyor belt and get the conveyor belt back to the production within a matter of hours, because with the traditional method, the repair normally takes about 2 to 3 days with around 10 people to do the repair on a conveyor belt. But with the polyurethane splice, this should be reduced to about 2 hours with 2 workers to install and repair the belt and get the plant back on running. And that would obviously reduce a huge amount of capital from the plant and help the profitability as well. Key point about polyurethane is that it is abundantly available versus rubber that is mainly planted and farmed in Southeast Asia. So what we are trying to achieve is to expand the supply chain and at the same time reduce the maintenance cost as well by proposing polyurethane to be used as part of the maintenance equipment. It's not only used on conveyor belts. You can have multiple other applications in construction, such as damping pads, or it can also be used as an adhesive as well. The key feature of a polyurethane, say, specimen is its exceptional abrasion resistance and higher strength. So we are trying to have a mix of flexibility and tensile strength at the same time, which is normally not achievable by any kind of other materials. Normally we see strength in hard materials and flexibility in soft materials, but polyurethane is something that is giving us both, and that's why we've chosen polyurethane. In the mining industry particularly, again, it's being used on conveyor belts, skirting equipment. So skirting is where a chute drops down materials on a belt, and you want to avoid the splashes or material loss on the conveyor by skirting the conveyor and avoiding materials bouncing outside of the line. We can also use polyurethane as kind of a scrapers that are responsible for cleaning the conveyor belt. Cleaning in long term would have major benefits in terms of lowering down the maintenance costs. Examples of use cases in construction is also waterproofing or expansion joints, and also vibration isolation pads that are used on offsite manufacturing plants. Pointing at the chemistry of polyurethane, it has two parts, polyol and isocyanates. When they are mixed at certain ratios, it starts to generate heat, and these two parts, each individually, will contribute to separate properties. So we basically call polyol as the soft part of the polyurethane and isocyanates as the hard part of the polyurethane. So you can expect to achieve higher strength by adding more isocyanate, and expect to achieve higher flexibility by adding more polyols. This is obviously depending on the application area where different flexibility and different strength are required. You can adjust the ratios and expect different outcomes. Preparation and mixing plus casting and curing are also some of the other important criteria that you have to take into account when it comes to preparing your samples. At the exposure, one key takeaway is that normally on manufacturing plants, when the equipments are washed, everything is prone to moisture, and once polyurethane part A and part B are mixed at the exposure of water molecule, it starts generating gas. And because of the low viscosity of normally polyurethane, those generated gas, that generated CO2 gas in particular, would get entrapped in the specimen and reduces the strength. So with all those efforts of stoichiometry and chemical considerations in effect, just simple exposure of moisture may just destroy all of those designs beforehand. But there's a catch afterwards as well. So once it's mixed, once part A and B are mixed, regardless of whether the moisture is present or not, it is highly recommended to degas the chemical compound to reduce and extract all the bubbles out of the mix before it is poured onto the mold. Mold obviously has to be used with demolding agents, so that once after 2 to 3 hours of curing in the temperatures between 70 to 90 Celsius degrees, the final product will be easily taken out of the mold. Moving on to the next slide. Preparation is a crucial part of having a final good result. Heating can also increase the final strength, but it might add some cost to the production line if you're planning to make a polyurethane mixing plant. Heating is something that must be considered. Stoichiometry, like I said, soft and hard part of the mix would determine whether flexibility will be sacrificed or strength will be gained, or vice versa. Degassing, removing bubbles would leave more place for the material to perform under stress, and therefore vacuum degassing is highly recommended before having a good mix. I'm probably just going to keep it as it is and move on to this slide, as the future of polyurethane splicers are laid with this self-healing property. Conveyor rubber, because polyurethane is normally going to be used as a replacement for rubber, as explained before. They all have an expiry date. After a certain amount of time, they start to get stiff and cracked in places where they are prone to movement. And that again would add another extra cost to replace them. But with some extra chemical modification and UV radiation, there are capabilities that can help the polyurethane heal itself. I was in the middle of doing the research on this one, but everything was in the lab. So everything was clean and there wasn't any dust, but one of the fellow tradies walked in and said, okay, you're working in a pretty clean lab. But what if I take it outside on the mining side, where there is sand, dust, and everything prone to the conveyor belt. If the dust gets into the cracks, does the UV still help the healing? And it was the time when I've just stopped that study until further investigation. So if you have any ideas on how to solve this issue, please let me know. If there is any self-healing substance that can perform in dusty environments. So future opportunities are endless. Polyurethane would provide so many endless opportunities compared to rubber, where supply chain is limited, whereas when the polyurethane is introduced in the market, maintenance costs can come down significantly, and due to the abundance, better features and better outlooks are expected. Yeah, that was it. Thank you so much.
Thank you so much, Farid. It was a great presentation. Does anyone have a question for Farid? Thank you so much.
Maybe just, sorry.
Go ahead.
Yeah, just a question. Is there any limitation identified in this research?
There are always limitations, but what kind of limitations are we talking about? Like in terms of tensile strength, just the polyurethane, for example, could achieve up to 32 megapascals of tensile strength. I couldn't get any higher than that. But obviously reinforcement, maybe we should put carbon fiber in polyurethane. What do you think?
I'm asking this, yeah. Yeah, all right. Okay. No, that's all from my end. Yep. Thank you so much. Just want to know this. Yeah,
can I make a little contribution?
Sure.
Hello?
Hello.
Yeah, can I make a little contribution?
Sure.
Okay. You talked about something that could work in a dusty environment. I believe the polyurethane can still work. Maybe if you have to dust first, maybe do some cleaning on the rubber before applying the polyurethane. I think that would be, you can check that out. I think it will work.
Yeah, definitely.
To enable better contact.
Yeah, better contact. Yeah, removal of dust would improve the contact. But the whole idea of a self-healing polyurethane was to not have any maintenance crew to go for inspection or cleaning. But then if cleaning is involved, why not just replacing?
Okay.
Matt.
Thank you, Timothy. Matt?
Thank you.
Farid, I don't know if you know this, but you're right on the edge of this thing that could really advance this area by a significant amount. I mean, when you deal with AI, obviously it's this foundational information that you're talking about. You know very well it's masterful. You see the dynamics. You have the interactions of all the chemicals. It's very workable in your head, right? And so there's this. We actually did a full paper on this on the materials project out of Lawrence Livermore Laboratories out of California. And they've got 522,000 molecules documented and have an AI interface. And so the opportunity is you take all that information you have in your head and that sense of what works, what doesn't, start asking this huge database. It's been around since 2011. Obama started it, and it's just a wonderful, wonderful tool. And without the, let's call it the grind of experimenting and, mixing and doing, some of this hard, tedious work on 30 items, you do it on the 3 items that really have the most promise through the AI, through the molecular attributes that are in there. And again,
So,
it's a way to take somebody's knowledge and really leverage it.
actually, can we kind of mix with the predictive model that you might have? If you limit the number of suppliers from the material perspective, it would reduce the chaos eventually. Having more predictability if the material supply is limited to some, say, reliable suppliers.
But the upside is that, let's say you don't do the 100,000 experiments by Thomas Edison, you do the 3 experiments that you know have the most promise, chemically and molecularly, and then you can go deep and suppose and make small variations and have a little bit of let's call it mistake, which opens up your thinking. It's just a good way to take something like this and just say, I really have the 3 answers here. I got to figure out which of the 3 is really the best answer, given all the factors like Timothy was talking about, and you've alluded to. There's other issues besides just the chemical composition.
I appreciate the input.
Yeah.
Thank you so much.
Yeah.
Thank you very much. So now we are continuing with Dr. Tahera.
Hi, everyone. Am I audible?
Yes, we can see you.
Yeah. Good afternoon to you, but good morning to me here in India. We are 4.5 hours back. And I appreciate and thank the entire team for giving this opportunity. While you give a second, I'll just share my slide. Okay, so myself, Dr. Tahera, and Assistant Professor, Department of Civil Engineering, Dayananda Sagar College of Engineering, Bengaluru, India. So I'll be presenting development of net positive stabilized mud block incorporating bagasse ash and bagasse fiber for sustainable housing. So this is the brief contents that I'll be covering up. Summary, what is the problem, how we have come up with the solution, and design model, impact analysis, feasibility, cost. We have not just restricted this research only for the laboratory. We also wanted to commercialize this product and give more opportunities. So coming to this summary, we actually came out with the problem understanding. So India is, of course, a populated country, and we mainly depend on mass housing. And definitely we have a SWOT analysis that we had done. So strength, weakness, opportunities, and threats. So here, when it comes to the strength, we made use of a local available soil, which is nothing but the red mud. So we have abundant here in and around, and we made use of this agri residual waste, that is agricultural waste, sugarcane bagasse and the fibers. Again, the neighboring district, Mandya, we have n number of factories, sugarcane factories, wherein we can procure this material. And we wanted to look into minimizing the cement. Of course, it is making a huge talk of the town, saying that the cement is one of the main cause of carbon emissions and things like that. So when it comes to this weakness, yes, there is so much of potential that we need to come up with new products, new market strategies, and whatever the product we have to come up with validation. So when it comes to opportunities, yes, again, there is a growing market. We have to take up certain rural initiatives, and there is need for enhanced durability and less maintenance. And when it comes to threats, whatever the product we come out with, definitely we have to take a risk. We need to compete with the existing market. So basically, by analyzing all these things, and looking into the statistics of how our India is one of the leading sugarcane production, and after Brazil. So after Brazil, we are the second largest. Considering the states Uttar Pradesh, Maharashtra, and Karnataka, these three states itself produces 75 to 80% of sugarcane. So looking into all these things and analyzing the problems here. So yes, since we are dependent on the mass housing, we make use of concrete blocks, we make use of fire burnt bricks, and there is a limit accessibility, and the costs have gone high, and there is a need for solutions to reduce the carbon emissions. So looking into all these things, the objectives what we framed is to develop a low carbon sustainable block, make use of agricultural or the industrial wastes, and enable the local production and making it into a commercial product. So this is the solution that we proposed. Collect the agricultural waste, all this sugarcane, bagasse, ash from one of the neighboring district. We collected the bagasse. We incorporated the red mud with partial replacement of cement by fly ash, then bagasse ash, bagasse fiber, and water. So we made a novel mix of this. And why red mud? Red mud is rich in alumina, silica, and you can see the color here. It is rich in iron oxide, which in turn imparts a good strength. That is a major constituent of this mud block. And then cement, in a conventional block, usually the cement what they use in order to stabilize, to enhance a little bit more strength and to have some pozzolanic activity, the cement usually used is 20%. So we wanted to aim to reduce the cement content and also make use of different alternate materials. So we used fly ash by reducing cement and adding up fly ash. And why fly ash? This definitely has a very a good slow pozzolanic activity at long terms. And then yes, we have a late strength development. And bagasse ash and bagasse fiber, ash definitely it had given us a good package density, and fibers, it is good enhancing the tensile strength. So we tried to come out with a mixed proportion, and we made a novel mix, and at a laboratory level we prepared our own mold, and we used the compression testing machine itself to compress the material, and finally we got this stabilized mud block. So basically we did all the strength test and all the tests in order to know its characteristics, properties. So for red mud, specific gravity, sieve analysis, liquid limit, plastic limit, and all these tests were carried out. We obtained these values, we compared with the permissible limits as per the Indian standards, and definitely all the materials passed the permissible limits that was required for construction. And when it comes to the tests on blocks, we checked with the density, water absorption, compression strength, and efflorescence. And yes, mix 0 is the conventional block wherein only red mud and cement was used. And we tried to keep the constant quantity of red mud, cement, and fly ash, again by reducing cement. And we varied the bagasse fibers and ash content in order to see how exactly it behaves for different mixtures. And then when it comes to density, it was more or less almost the same, with even though we had different mixtures, and water absorption was almost proportional to the content of fibers. More the fibers, there was much water absorption effect. And when it comes to compression strength, the combination of this ash and fiber, probably it has given a good strength for the mix 3, which had 4.2 MPa. Usually the compression strength of blocks, that is compressed mud blocks, will vary from 3 to 7 or maybe 10 based on the material constituents. So this was the effect, and we did the efflorescence, and the one which had more fibers, you can see here in the image mix 4, it almost deteriorated with the test, and the most optimum was mix 3. And with this material, we also went to the actual factory and we gave the material. I can just play like 5 seconds video here. So our material was tested with a prototype, interlocking blocks. So this was the real time trying to know how exactly it comes out with. So definitely the impact was eco-friendly. It accounted for circular economy. It's rural friendly, more durable, and water resistant, and low tech scalable process. A very simple net positive sustainability quantification was done, and with the materials that we had and with all the calculations, we came out that there was definitely a reduction of 30 to 45% of carbon emissions. The more you reduce the cement, definitely we can relate that to reduction in the carbon emission. And a simplified life cycle assessment was also done with respect to, and when I say life cycle assessment, it includes materials, man, transportation, and power, manufacturing, also end of the life. So this material was helping in waste utilization, local production, air cured. The curing was actually a simple sprinkling of water for 3 days was much more enough for the curing, and it's definitely a reusable and crushable material. And when it comes to
Oh, I think Tahera has a bad internet. Let's wait. Oh, that's such a shame. Maybe we'll have to continue with the next speaker and then we can ask some questions at the end to Tahira. So let's keep going with Maureen, please.
Hello, everyone. Hi,
Hello.
my name is Maureen, and I'll just share my screen now. Just a sec. Can you see my screen?
Yes, we can.
Okay. You can hear me. All right, then. Okay, so like I said, my name is Maureen, and today I'll be speaking about the automatic sorting process in construction and demolition using artificial intelligence and digital twin technology. So for this presentation, I asked a couple of questions. It's still ongoing research in this, but like just to present the questions and put them out there so we are considerate and just get into the point of that. So the first thing to ask is why this topic is important and why we are doing this now and why we should do this. We look at the construction that is the industry itself and how much waste that is generated from this. And I think that the first thing I wanted to ask was the psychology behind this. And when we see that some of these items are considered zero value materials, and that's why they end up in landfills anyway. So we are seeing that the numbers are staggering though, because you see that in 2025, the global annual construction waste reached 2.2 billion tons. And this is when you consider the fact that construction and demolition waste made up 40% of that waste. And in addition to that, you now consider the fact that it was from municipal and it was more than municipal city and solid waste and industrial waste put together. So, and that also tells you that, of that waste that is generated, concrete has the longest life, usage, like usage after, and it made up about 40% of that as well. So to make these numbers clear is to say that in the waste, all of the waste that's generated globally, now we have 40% of that being generated from C&D, and then in that 40%, we have 75% of that generated from concrete in that. So that really tells you that, and the irony is that concrete actually makes up more and can be used later for this. So AI can help us reduce that to about 70% of the material recovery, and this is what this research asks and questions that we raise with this. Of that waste that's generated, we have some that are generated from copper, aluminum, iron, and asphalt and shingles and all of that stuff. So these are valuable things. So the real question is, why are we not doing more of this? There are many challenges with adoption, but I think the first thing is that when we look at the current most popular methods, we still come down to manual sorting, which is not attractive because of the time that's wasted in this process and just the underutilization of labor. So people who do this can be reassigned to higher level, just less monotonous work and just doing something that's a bit more, a better use of their time. And it's just not effective, to be honest. So we have about 30 to 40 picks per minute with manual sorting, and AI can help us do this about 80 to 100 picks per minute. So it's a bit more, effective. There's also an information asymmetry where you have the people on the field, like the constructors, do not really know the value of the items that are being disposed of. And then it comes back to the psychology that I mentioned before as well, that people just are not as aware as they should be. And then the problem with safety is that the materials from recycled aggregates are very heterogeneous. Like you can't really, in a landfill alone, you're going to be able to see materials, contaminated and gotten from many years ago. So you can't really vouch for the safety of that material. So that really creates a problem with just trusting the process to use that. And then, like I said, this brings us to a second problem, which is the trust deficit on the structural engineers' part, where they start to ask questions about what the integrity of this material is in comparison to virgin quarried materials, which are safer, which are verifiable, and just verifiable by the geology or the land itself, or has a more national and follows a more national and international standard. So that creates a complication in that process. So in that way, there's also the biggest problem with alkali silica reaction risk, which is very important because, with this risk, even when the houses are demolished, that you now have problems with getting them back up again. And even if you use those materials again, it can start another reaction within that process. So they are right to ask these questions, and that it's not that the structural engineers or civil engineers do not want to use recycled materials, but these questions are not being answered properly. And this is why, there is still that resistance or hesitation to use these materials. So how do we try to get into solving the problem? I look at this from two pillars. I start with, artificial intelligence, where we look at the pre-processing and just, the whole process and how to introduce a more effective, system that makes everything better. And we start with pre-processing. And this is not really an artificial, this is more like a mechanical engineering process where these things are broken. And just, the idea behind this process is to break it into manageable bits that can be put into the system that is, able to go through the conveyors and all that. And then we have the magnetic and eddy current separator, where this is sorted out for ferrous and non-ferrous materials. We need this because, and this is actually where the most value is, that all of the copper and aluminum and all of the iron and all of these things are sorted properly to get the most value. So this is the best part to be able to recoup some of that investment, or not to experience as many losses, and just to be able to get all of that back. So this The next thing to do would be to go through a near-infrared spectroscopy. This is to further classify and, break down the arrangements to know that you're able to separate, wood, and then further separate, within plastic, you're able to separate like PETs and PVCs. And so this helps with that process as well. And then you have the 3D vision guided robotic picking, which is also an improving technology. As you see that before, I think now there was a problem with the degree of movement and just picking irregularly shaped objects. And this is a problem that is getting solved more and more. Even with near infrared, there was a problem with color grading and just not being able to pick up black, but that is now, something that's getting solved. So daily and well, as we go ahead, that there's more, advances in this, but there's still potential for work to be done in these spaces. So this entire process really cuts down, and that helps us with the numbers that I mentioned earlier with, reducing that human stress and just, making a more effective system that helps us achieve that 80%, 80 to 100 pics per minute that I mentioned with AI. The second pillar of this that I've considered is digital twin technology. So digital twin is essentially like a replication or just creating an infrastructure that is able to mimic or just reflect the reality of a building and show the material journey of that building, which is verifiable, which is account accessible and can be traced over time. So digital twin technology is really popular in building, of course, but also with for satellites or rockets and things that we cannot constantly check, just making sure that due to the weather conditions, according to it has followed other conventions, and based on that we can actually see on a digital twin how the actual physical asset is performing in space or wherever it is, and we're able to maintain and detect, more importantly, when maintenance needs to be done. So there are 3 stages to this. You have the material twin, you have the asset twin, and the system twin. The material twin is going to be what I'll focus on because that looks at the very, very small item itself. So basically the batch of the production. So it looks at all of the things around the protocol, just, if it has followed everything, and then it starts to look at the assets, which is the building itself, and then a system twin, which looks at a city, which just looks at how it is integrated with the assets and other geographic factors like recycling or following a sustainable development process in that stage. So as you can see here, we're also able to detect the environmental sensors, structural health, and the building information model, which is the BIM, and then just looking at inspection records. So the digital twin can show us that information. So this answers many of the questions that the structural engineers have and the hesitation that they have around adopting this. So we look at something called the material passport, which then follows the supply chain, and throughout the whole process, we're able to generate something that shows you what the location these materials have been in, and all the trauma it's been through, so to speak. So when you look at a landfill, for instance, you have items that have been thrown there from the 1990s and 2000s, and all of these things. So there might be contamination with asbestos. So this shows all of that, and this is what the structural engineer. So with this, you have a material passport, which is maybe scannable by QR code to show this is a verified item. There's no alkali silica reaction, and then all of these things can be safe, and then the engineers and civil engineers can trust the process a bit more. So we'll look at examples of this where this has been done, a case study of this, and I think the best example is Diaz, the diamond company. So Diaz is a mining company, and because of the problems with the issues around diamond mining with blood diamonds and all of that stuff, people need to be sure that they're making the ethical choice to buy diamonds that have been ethically sourced, and they try to do this with a tracer technology, which is similar to a material passport, which is a material passport, not similar to it. So you have the mine, and it shows a ledger, it shows you information. So this is a screenshot from the tracer platform, which shows the provenance. So basically the origin of the item, shows you the date, the country, and a lot more information. So this is the ledger it's a really comprehensive document, very exhaustive, that shows you everything that's got to do with the diamond that you're getting. And I think this can definitely be applied to building, like, in that structure or process, because it shows you the passport. So we have a structure, and then it can tell you the material passport, which you can then scan, and you can be able to certify that this now gives you a structure that you can trust. Going ahead, so this is what Diaz has done, and then I'll also look at a country case study. I think the best country that I found to do this was the Netherlands, which has the world's most advanced material passport system. So the Netherlands really looks at how this can be done, and this is doable and can be executed if done well. And this is a building called the Circle Pavilion in Amsterdam. It's with this same technology, and it's being used. And so all of the items here have been tagged, and there's a system. So when there is a demolition of this process, that there would be constant passport to show everything and all the items, so that these things can be reused. And this is in line with the Dutch government's need to have a fully circular economy by 2050. So circular economy really looks at how everything goes through the whole process, as opposed to the linear process that we have of extracting from the ground, using, and then disposing. So a more circular way would look at which was proposed by Ellen MacArthur, to show that this can actually have a life. So this is handled by a platform called Madasta. Madasta looks at just how to process and provide the passports that are available in these places. And then from that, they look at the value of these items and how they can be used further. And this is adopted in countries. It's been successfully adopted in countries like Germany, Belgium, and many parts of Europe. Another country that would be another example, but I don't want to go into that because of time, is Singapore as well. So Singapore has a thing with landfill being a problem for them, and it's more like a necessity for survival for the country. It's a very small island, so they have only one small island that's going to be full, and it's going to be at maximum capacity in 2035. So they are coming up with digital material passport technology to handle this effectively. So yeah, this can be done. It's possible, and I think it's something to consider. Thank you very much.
Thank you so much, Maureen. Really great presentation. We appreciate your time. So does anybody has a question for Maureen? Go for it.
Thank you so much, Maureen. It was very intriguing, very interesting, a lot of interesting new knowledge. Just something that I couldn't connect was the digital twin and automatic sorting for construction and waste demolition. Are we looking at something like having an operation room where all the operation in a recycling plant is being monitored? Is that another translation?
Yes, in some way, but then again, in some way, it's not really. It's just an update system to show that this is so based on after 5 years, we should know that based on weather conditions in these regions, this should have happened to the building. So it's not really a control room where everything. I don't see that's something that we've done constantly. Of course, there are people to watch this and make sure that it happens. I think that it's more like over time, with wear and tear, with any trauma, any natural disasters. The building should be going through this, and this is what we expect in that time. Yeah.
Okay. Speechless. Thank you.
I think Hala has a question. Please.
Yes, thank you. I was looking for this function. All right, yeah. Thank you so much for the presentation. Very nice presentation. Now, I just interested to know regarding the digital twin, how can digital twin technology contribute to a circular economy approach in construction industry?
Yeah, so it helps with the reuse. Like I was saying, that it's a problem with structural engineers not wanting to use them because they feel like it's not safe enough. So with the problems with like alkali silica reaction, asbestos contamination, they really want to know that these things are safe enough. So with with engineer assurances given to them by government regulation and other standards that are set around this, that there'll be more confidence in the use of this. So you start to look at services around it's called SaaS, like sorting as a service. You would now start to see companies that offer this. So you can now scan a QR code that tells you that this is verifiable. So they sort of move that, because engineers also have a problem with following the code of ethics, and they have to follow that ethics. But if there's a company that's able to provide or give them an assurance of sort, then they'd be more comfortable. The reason that they're not using it is not because they don't want to use it. It's just that they feel like they're not confident in that. So that gives them more confidence. I'm sure so that leads us to a more circular use of that.
Thank you so much. I just did a quick search here, trying to find, is there a published paper from your end regarding this?
It's just ongoing research. It's presentation, and with the research, I'll continue to work on this. Yes, I'm currently working on the research.
Yeah, out of curiosity, I would like to read more about this. Yeah, thank you so much. Thank you.
I'll share with you if I'm ready.
Yeah, thank you.
Thank you.
Thank you so much for all the questions. Now we are following with Mr. Kwawdwo, with his presentation. Thank you.
Right. You're welcome. Good morning, everyone. Please, are you able to hear me?
We can hear you.
Okay, beautiful. So I'll just quickly share my screen. Okay. Okay. Good morning once again. I would like to sorry. Good. Okay. Good morning once again. So I would like to share on the topic investing in automatic sorting machines for construction and demolition waste recycling, whether it is worthwhile. And I think I want to thank Ms. Maureen once again for laying the foundation for my presentation. So a lot of research is being done to curtail the problem of construction and demolition waste construction and demolition waste because of the problems that they pose to the environment. So I'll quickly go through some basics of it's just an add-on to what Ms. Maureen shared. So the menace of construction, this is an overview of the presentation I'm about to make. The overview, the menace of construction, the sorting methods, comparative cost analysis, return on investment, advantages of the automatic sorting machines, revenue streams, conclusion, and then references, and then yes, I'll come to the end of the presentation. So construction materials are solid waste arising from construction, demolition, rehabilitation, refurbishment, or infrastructural projects, as was shared initially by Ms. Maureen. And this creates a lot of social, economic, and environmental menace that do not really help the environment. So a lot of research is being done to curtail the problems that they come up with. So I'll just go into the types of construction and demolition waste materials that we have. We have the inert and then the non-inert materials. As I know, the inert materials examples are like sand, and then concrete, and then non-inert ones are the hazardous, and then non-hazardous ones like the plastic, and then the hazardous ones like the asbestos. All right. So these are some of the problems that they cause in the environment: rising landfill costs, high disposal costs, depletion of natural resources, and then habitat destruction, and so on and so on. So the sorting methods that I'll be considering with this presentation, I would like to focus more on the comparative, to compare the cost of investing in automatic sorting machine as well as the conventional sorting methods that we use, whether it is worthwhile to invest in the automatic sorting machine. Yes. So what I'll consider is the manual sorting is what we normally use as in Africa. We not really, most of the construction sites resort to manual handling. There's no use of other machineries like conveyor system and all that. That one is used for the waste management companies that sort all the waste streams. So in the more advanced countries, they resort to the conventional sorting. And then this presentation is actually based on a research that has been done. It's a case study that has been done in Finland regarding the conventional sorting machine and an automatic sorting machine. So the conventional sorting machine employs the use of mechanical machines such as conveyors, shredders, and then magnetic separators, as well as labor. And then the automatic sorting machine uses purely machinery and then technology, as Ms. Maureen laid emphasis on earlier on. So with a conventional sorting machine, like I said, the process is labor-based, intensive, and can be inconsistent due to the human errors. And then they're also assisted by mechanical tools such as conveyor, shredders, and all that. So the processes that they go through is just what I've illustrated in the figure here. So it goes through stages. It goes through these stages, like from the stockpiled of, if you stockpile the whole CD waste, the first process that it goes through is the excavator collects them and then feeds them to a shredder. This is the conventional one. Because of the bulkiness of some of the waste, it needs to be shredded before it can be handled by the laborers, by the humans that are working with these wastes. So it goes through the conveyor system, then it goes through the shredder, then it goes through, yes, just as I've laid these various stages to be able to be sorted out eventually. Yeah, so these are the disadvantages that goes with the conventional sorting methods: the slow manual process, high labor dependency, low recovery rates, and then health and safety risk that is connected to the laborers that are employed to go through these sort of activities at their workplaces. So when the automatic sorting machine basically uses the sensors and then the automation through computer vision, robotics, and artificial intelligence, as well as a conveyor, as well as the conveyor system. So I'll quickly jump to, so this is an example of a machine learning based automatic. This is actually in use in Finland by Zen Robotics. They've actually manufactured this and it's being used. So I'm coming to do a comparison between the conventional sorting system and then also the automatic sorting system. So in the analysis that I'm about to do, the following assumptions were made. There were assumptions that were made so that it's the research or the presentation will be justified, because the output of the conventional system was 70 tons per hour. That's the conventional sorting facility that was used in this research. The output per hour was 70 tons, and then the other one for the output for the automatic sorting machine was also 30 tons per hour. So in order to be able to compare both of them, the conventional system was actually multiplied by a factor or divided by a factor to be able to have the same output for both conventional and the automatic sorting system. So I don't want to go through all these assumptions, but at the end, okay, so let's go to, I think this is important to note. So when you're considering the okay, so you're considering the conventional system, you see the labor requirement is about 20 during some of the separation sections, and then at the final quality control, the manual sorting, you need 4 laborers. So in a total of 24 laborers, but with the automatic or machine learning based process, you only use only 2 laborers at the end of the final sorting. Yes, so you see the number of labor requirements for the conventional system is really high compared to the automatic sorting machine system. So in this case, when we're considering the the cost benefits analysis, result of comparative cost analysis. So what was considered is the facility cost. The facility, that's the facility that you're going to do the whole sorting operations in, and then the cost of the machines, and then the cost of employing those 24 personnel and all that. Everything has been combined, and then this is the result. So in the first year of operating with the same output, the first year of operating the automatic sorting machine, the first year, the cost that that was incurred in the research was 9,400,000, around over 9 million euros in the first year. And in the first year for the construction, for the conventional sorting machine, you realize that it's a bit lesser than that of the automatic sorting machine. I think this is because of the automations and the robots, the cost of the automatic robots, and then the initial machinery that you will need to actually set up the place to set up the system for the automation for the automatic sorting machine. So, and the second year, you can see that let me use this graph to do this explanation. So you can see from the graph here that in the first year, the conventional sorting machine incurred over 7 million euros. And then the automatic sorting machine in its setup incurred 9 million. But in the second year, when you go back in the second year, the subsequent years, the operational cost and everything for the automatic sorting machine reduced to 568, less than 1 million. But the operational cost and then the maintenance cost and everything for the conventional system increased to 2 million. That was the subsequent years. So this research was done for a period of 7 years. So the first year for the setting up and everything and the operational cost, it's for the automatic sorting machine. The initial cost was really high because of the investments into the automations and the facility and everything, setting it up. And then in the conventional system too, like, it was a bit expensive, but a little less than the automatic one. By the subsequent years, because of the the high operational cost in with the conventional system, it's increased the cost of operation increased to 2 million, which actually is a bit high when you want to operate such a system for 7 years. So for 7 years, if you are you are incurring every year, if all things being equal, if you are incurring 500 less than a year, less than a million to operate an automatic sorting machine system, and you in the same vein you are using 2 million to operate every year, you see that it is worth investing in the automatic sorting machine. But the problem with that is the initial cost of the automatic sorting machine. Because of the automations and the machines that are involved, you need a lot of capital to be able to establish it. But looking at going forward or in the future, I think it is worth investing. It is worth investing in the automatic sorting machine. So this is just a return on investment for the automatic sorting machine. So if for justification of the automatic sorting machine, the first year, the amount that you use to set the place up, your revenue should be able to meet up. That is to break even. Your revenue should be able to meet up with this amount that is the total cost that you incurred in establishing the automatic sorting machine. So even with a simple calculation of if you are able to get a revenue the second year that is also equal to 9 million, I think you're going to, without going further into all these calculations, you're going to get like if the subsequent year the subsequent year was less than a million. So subtracting say this 500 from this 9 million, that is if that is your revenue base for every year for the 7 years, you're going to accrue a lot of profit. You're going to make a lot of profit, and I think it is worth investing in such venture. But okay, so the advantages of investing in automatic sorting machine as against the conventional sorting machine. So it has a long-term profitability through reduced operational costs. Like I said before, the cost of establishing it or the cost of setting it up initially is a bit expensive. But when you want to look at the long term, in the long term, investing in automatic sorting machine is worth the goal. And it has a higher, based on the research and then the findings that came out, it has a higher recycling rate, improved efficiency, and then the waste materials that come out of the sorting are purer than that of the sorting, the conventional sorting machine. And it can also be used in areas where labor shortage because of the very few laborers that you will need to operate the automatic sorting machine. Basically, you need 2 people at the end of, based on the research or the findings of this presentation, is just 2 people that you will need at the end of the sorting, as against the 24 laborers that you will need in going through the conventional system. And for environmental and circularity advantages, as was presented earlier by Ms. Maureen, for circularity, to be able to use waste, to be able to recycle waste and then give them a longer lifespan, I think the way to go is the automation type of sorting materials. So these are revenue streams. So if these if you're able to set it up and then you're not able to hit the revenue the revenue targets that you've marked for the whole investment. I think that's where like it will be difficult to go in for such a venture. That's if your market is not really ready. So if to be able to go into such or invest into this automations and which has caused a lot of research and then a lot of work that is being done to curtail the menace of construction waste and all that. There need to be a setup market, a setup like a market that is ready to be able to use the recycled materials, so that it will be able to pay off for the initial investments that really goes into setting the automations, the automatic sorting machines up. And there also need to be government incentives, as in subsidies. There can be partnership because of the great advantages and then the profitability aspects in investing in the automatic sorting machines. I think it would be best if the government and then the private people can enter into some sort of partnership to be able to set these up at various municipalities or wherever necessary to be able to curtail or to be able to handle the issues of construction and demolition waste. Yeah, so in conclusion, I said that there must be formulation of policies to encourage the automatic sorting construction industry, to facilitate industry or to facilitate Australia's transition into circular economy, policies to boost the markets of recovery and recycled materials. So these are the references that are used. The first one is actually where the research was conducted. Yes. I think I've come to the end of the presentation. Sorry, I was a bit nervous.
Yeah, nice for your presentation. Thank you very much. Does somebody have a question for him? Omar.
Yes, thank you. Thank you for the presentation. It was a good presentation. You were not nervous. Nobody noticed that.
Oh, really?
So I probably have I have just a clarification and a question. Maybe maybe I missed it. Was this comparison done by the two ways within, and they both had the same production rate of 30 tons per hour?
Yes, it was the research was done in Finland. Yes,
for
in
the same production rate. So both methods had the same production rate.
For the same production rate. So the conventional sorting machines actually has an output of 70 tons per hour, and then the automatic sorting machines has an output of 30 tons per hour. So in the cost analysis, through the computation is you need to divide or multiply a factor. That's 2.3. You need to divide the 70 tons per hour by the 2.3 to be able to get the same output. That is
so the conventional was double. Okay, almost double the size.
Yes. Yes.
That's what you're saying. Okay. My question would probably be in this case, did you look into how much space was saved if using an automated system rather than a conventional? How much space would be saved from a management plant if an automated system were used? Was that looked into or no?
Okay, from the research, from what I gathered, they did not mention anything like the space, but it talks about the facility, the cost of the facility. So they basically using in this comparison, they basically using the same space or facility that will give you an equal output.
Okay. All right. Thank you. Thank you very much.
You're welcome.
Thank you so much. So does anybody else has another question for Kwawdwo? All right, we are gonna keep going now with Dr. Isaac Akomea. Please share your screen. Thank you so much.
Hello, good afternoon. I hope you can hear
Good
from me.
afternoon.
Can you see my screen?
Yes, we can, but it's not in presentation. Yeah.
Okay, thank you for the
Thank you.
opportunities to present. So my name is Dr. Isaac Akomea-Frimpong. I work as a lecturer at Essential University, which is in Sydney, or here in Australia. I completed my PhD almost 2 years ago at Western Sydney Uni. And my area of specialization was project management. So today's presentation is on Agentic artificial intelligence for construction material and cost management in Australia. So currently this project actually started not too long ago. It's almost 2 months. I'm working with a team. So what I'm going to present here is more just the initial aspects of the project. We are yet to go for ethics application, and we are still doing literature review and developing models for the work. So I'm just presenting on aspects of the work to you. So I'll start. So as we know, construction projects face persistent challenges, and these challenges range from risk, cost, material wastage, demolition as Kwawdwo presented, and then issues of inaccurate forecasting. So over the years, one of the solutions that we have seen is helping us to resolve some of these challenges, especially in recent times, is artificial intelligence. But artificial intelligence comes in so many forms. And when I say so many forms, I'm talking about there is an evolution of artificial intelligence from its traditional or general form, transformed to generative AI. And out of that, we got a ChatGPT. And then came the AI agents. And now what is in, or what is even coming in, is the agentic AI. So in this study, the aim is to look at how we can use agentic AI to overcome some of the challenges relating to construction materials and cost management. But first, let's look at what is agentic AI. What is it? And then I will go ahead to also give you the difference between agentic AI and then ChatGPT, which is generative AI, and then agentic AI agent. So agentic AI is an autonomous decision-making, fast execution, and continuous monitoring AI tools. Unlike the traditional generative AI, they act by themselves. They don't just produce outputs, but they have a capacity to do multiple tasks, including planning, adaptation, system-level coordination, and predictive reasoning. This makes it different from generative AI, where you put in a question or you just put in a query and then it will give you an answer. So what are some of the examples? So we have a number of examples now, but many of them are being developed. And OpenAI is leading this, as well as other AI organizations. So I have some examples here. So if you take one, I'll just go through one or two and then move on to the next for the sake of time. Like if you take Crew AI, for example, orchestrates teams of specialized AI agents. It has a capacity to assist researchers. So if you are a researcher, Crew AI can help you, especially those of us here who are into research, or we are PhD students, or we are master students. Crew AI can help you to get your work done. We have LangGraph. LangGraph is a tool for creating complex stateful multiple-step agent graphs, which is capable of giving feedbacks, and then it has the capacity to automate retrieves and results. And then Microsoft has also put out one called the Microsoft AutoGen. The Microsoft AutoGen is capable of giving you a setup which is more conversational, collaborative agent networks capable of helping you to solve complex problems through text communication. Also, Microsoft has also put out this Microsoft Copilot, which I think many of us are using or have used that before, but an updated version of Copilot or the Microsoft Copilot Studio is being put out, and the aim or what it can do is to give you a low-code platform which you can deploy to help you to share your data and also to help you to chat with multiple functions. Now, what are some of the differences between agentic AI, generative AI, and AI agents? So the agentic AI tend to be more proactive in a sense that it has the capacity to prioritize your work or task or whatever you ask the agentic AI to do. It has the capacity to plan, do more than what the generative AI can do. Also, another difference is that the generative AIs, as we all know, they are used to create more content. They are more content. They tend to be more content creators. Generative AI and agentic AI tend to be more content creators, while the agentic AI go beyond that. An example of an AI agent is Grammarly, which I think many of us will know. We all use Grammarly, or some of us have used Grammarly before. And other differences. I'll try to skip some of the things because of time. So how does it work? So as I mentioned, if you are using the agentic AI, unlike the traditional AI tools, including the generative AI, the agentic AI is capable of going through so many processes, as you can see from this diagram. So it has a capacity to plan, make assessments, come out with results, and if the results that you are looking for, you don't get, or it doesn't get the right results that is supposed to come out, it will go back and start the process again until the best results come out. So let me give you an example. So let's assume that you are looking for the cheapest flights from here to Auckland or from here to Melbourne. You are in Sydney, you are going to Melbourne, and you want to book the cheapest flight. So with the generative AI and even the AI agent, when you put in your query or your question or whatever you want to, it will just give you the affordable, the low cost price airlines, something like Jetstar. For those of you in Australia, you know Jetstar. And others, the low price one. It just give you a list. And that's what the generative AI and AI agent do. But with respect to the agentic AI, what it will do is that it will go ahead to make analysis of all the cheap flights available, And then, if possible, with either sometimes with your instruction or not, they can even go ahead and book the flights for you. To go ahead to look at the differences between all the flights, their policies. I'm talking about the flight agencies or companies, their policies, which one is better, which one is meeting sustainability targets, and the ones which are not meeting sustainability targets, their prices, too many things. To look at all these things and then come out with the best results for you. So that's the difference. Now, the research. So what I have explained so far is more practical, more industry related, but research. So why this research? So what we have done, I'm doing this research with my team, and we are 4. One is in the University of Adelaide, one is in the Central Queensland University, and then one is in Western Sydney. So we are 4 that we are doing this research. Why this research? So we went into the literature, we checked the literature, the papers published on this topic. And what we got to know that most studies are focused more on generative AI. Current studies, if you go through the literature now, you go through Scopus Web of Science, Google Scholar, what you see that most studies are focused more on generative AI, and then the general, what we call the GAI, which is the general AI. Most studies are focused more on that, with the limited studies on agentic AI. So we decided to look at that. And another thing also is that the current AI tools, as I've already explained, they help you to get results. They serve as more of like search engine, just like using Google to search for anything. But they don't have the capacity to go ahead and do some analysis and give you the results that you want. So that is what we decided to research into, or that's what we decided to go into, and then find solutions to that. In addition, as we know, construction materials, construction costs face a number of challenges, or they are facing a number of challenges. Why? Because the issue of time, poor management, scheduling, and then also with an evolution in building information modeling, enterprise resource management, and site data management, there must be a model that can accommodate all these shortfalls in the existing models and technologies to help us to manage construction materials and construction costs. So what's the aim of this research? Well, so the aim of this research, or the purpose of this research, is to investigate into the agentic AI in construction materials and construction cost management in Australia. But some of the objectives that we decided to come up, but this is not all the objectives. There are more than this, but just some of them, is that we aim to assess the roles of agentic AI. In this, we want to know the specific roles that they play, with not just the roles, but we will come out with cases, examples, areas, specific projects where agentic AI have been used. And I also want to examine the relationship between agentic AI, construction costs, and construction material management. And then we also want to look at other moderating factors like issues of green finance, leadership commitments, and then industry policies. So we want to look at all that and how they affect the adoption of agentic AI in construction material and cost management. And then we want to come up with practical frameworks. Even though these frameworks are not something that we are going to impose on the industry, but we will come out with something like this, something like a guidelines, which we have done some in the past in some of our grant projects. Okay, so this is a conceptual framework. And in this conceptual framework, we propose that there is a relationship between agentic AI and construction cost management. And then also there is a relationship between agentic AI and construction material management, as you can see. And then leadership and green finance tend to moderate the relationship between agentic AI, cost, and materials. So this is the conceptual framework that we have put together, but we are going to modify this based on your suggestions. And as we continue to look into the literature, if we find something new, we're going to modify, but this is what we have as of now. Now, what is the methodology? So in this study, we have adopted, or we are going to adopt a mixed method. The mixed method, because we are going to use quantitative and qualitative analysis in this context. Quantitative in a sense that we are going to use questionnaires, one, and then we are also going to use secondary data. So what we have planned to do is that we are working towards getting secondary data from construction firms in terms of the construction materials and the construction costs. So we tend to use all of that in this research. And also interviews. Why interviews? The interviews, because we intend to talk to some of the industry leaders and project managers and some of the construction professionals. When we finish putting together the frameworks, the guidelines, we will find out whether these frameworks and guidelines will work for them or they will not work. So interviews will be important in terms of validation of the outcomes of the research. How many participants? We anticipate about 300 people will participate in this research, both questionnaires and interviews. But from our experience in doing a number of research in Australia, the truth is that it's quite difficult to get people to participate, especially when you are dealing with primary data. But we will do our best. But we are expecting about 300 people will participate in this research. But it may be lower than that. So that's our target, but it may be lower. Using purposive and snowballing sampling approach to get to people. What method are we expecting to use? So we intend to use, in terms of the quantitative, we intend to use structural equation modeling and system dynamics to analyze the outcomes of the results. And in terms of the qualitative, we intend to use either content analysis or thematic analysis to help us to analyze the research. So this is the proposed timeline, because the research just began and it's ongoing. Currently, we are the researcher in design of data collection instruments. So we are designing our interviews and questionnaires, and we expect that maximum from now till September should be done. And then from there, we'll go for ethics. We want to put in the ethics application. We'll take it through either Western Sydney or Essential or Adelaide, University of Adelaide or Central Queensland, any of them. We'll go for ethics. Once ethics is approved, we'll go ahead with the data collection. And then we are expecting that from January to June 2027, data analysis and the reports, including journal articles, will be done out of the research. So yeah, thank you. But before this, the conclusion. The conclusion, we expect to come out with predictive relationships and models that will support agentic AI, cost, material management for project. And the study, we expect that will have a lot of implications or contributions. One of them, practice. In terms of practice, we expect that it will have impact on decision making and cost management. In terms of future research, it will have impact on sustainability to the same. So thank you very much for the opportunity. If anybody has a question, please you can ask.
Thank you, Isaac. Really interesting topic. Does somebody has a question?
Hello.
Yeah.
Yes, Isaac, thank you very much for the presentation. Very interesting topic, by the way. My question would be in the scope or the questionnaire or the 300 stakeholders that you're anticipating to have partnership with. Will this include any particular project size? Well, like, is there any particular size for the projects you guys will be targeting, or it's just going to be any type of project?
Okay, for now, our plan is to look at any type of project. We are going to make it open. And the reason why we are going to make it open is from our experience, because we have been part of a number of grant projects, and when you are trying to get people to respond to your questionnaire, especially in Australia, it's quite difficult, especially if you decide to focus on one specific project, let's say maybe a road project or railway project or buildings or something. It's
Yes.
quite difficult. But when you make it open, you tend to get more responses. So for now, it's open. We are going to make it open. Yeah.
Okay. So I guess the reason why I'm asking this is that because sometimes in some projects, the cost could be a restricted information to share.
Yeah.
And hence it will be very, very important to identify or at least put a target of what types of projects
Yeah, I agree.
is involved in this study. So
Yes.
it makes it much clearer to the audience. Appreciate it.
Okay.
Thank you.
Thank
Thank you very
you.
much, Isaac.
Thank you so much. To add to that, yes, I agree with you, because even trying to source information or cost data for specific projects sometimes tend to be difficult. But once it is open, we are hopeful that we'll be able to lay our hands on something that will support us to do this work. So open.
Yeah. Good luck. Good luck in that.
Thank you.
You're gonna need a good luck with that.
Yeah, thank you.
All right. Have a good one.
Thank you. Any other?
Okay, I have
yes.
sorry. I have a question.
Yes,
Not
please go
not
ahead.
rather a question, but something to add to your presentation. So about the agentic AI, I think with the work with the project, the research we are doing about the instant quoting for construction, small construction businesses. So I think the agentic AI would be something, would be a plus, especially for construction material cost, which I think would be like, it's a foreseen problem that we're going to face in our research, like getting the suppliers and suppliers of the construction material to give the actual price for our instant quoting for the client. So I think with this your presentation, maybe it might be a collaboration with you to maybe to have to find a way to solve this problem, because I'm thinking in a way every business or every supplier wants to get customers, wants to get a gain for like from their business. So in a way, if we are able to develop this our instant quoting for small construction businesses using AI, I think if we make it a way that is going to be profitable for the suppliers, so we create a platform whereby they can easily upload their cost material and everything on the software that we're going to develop, which will make it very easier for like the small construction businesses to be able to get accurate price and cost of any project that they want to do. So I think this is really nice, and hope to collaborate with you in the future.
Yeah, yes, we are open for collaboration. So I'll be happy that you can collaborate with us, because one of the things that we are even finding it difficult to get is, as Omar rightly put it, is getting data from these projects, construction firms and then suppliers. it's kind of difficult. But with your idea, I think we can create a platform where we can get either information or we can create something that will support the suppliers and then the construction managers. So that's a good idea, and I'm open to the collaboration. Thank you.
Thank you very much.
Thank you.
Can I also ask a question?
Yeah, right.
How are you, Isaac? Been a long time. Thank you.
Long
You
time.
can see from the number of questions that it was a pretty interesting topic. Complementary to what Franklin just mentioned, I think he was pointing out to something called an API for real-time monitoring and real-time analysis.
Great.
Like you said, it's a bit hard to establish data collection, but if you're talking about predictive analysis and having an AI to be connected to kind of a database, we might have to think about having an API as well. It was just an suggestion, and I have an offer as well that since the institute is kind of invested in the data analysis and AI, we are happy to help with providing servers. If you needed any kind of computation, we are happy to provide that.
Okay, thank you very much. It's something that we have discussed among among the researchers, those of us who are putting together this research about the issue of API and then getting something to support that. So we, on behalf of the other researchers, we welcome that with the institute, we work with you so that we establish the API. That will help us.
There's an infrastructure available and we're happy to help.
Okay, thank you. Thank you, Farid. Is any other question? Okay, yes, Hala, please go ahead.
I just have this question because it's in the area where I'm teaching. So this is related to cost management. I just would like to know what measures or factors are needed for cost management to prevent any errors in AI decision making.
In terms of the errors, it's more project specific. I think it would be very difficult to give you one answer because projects differ. Because what issues concerning, let's say, road project is different from issues concerning buildings or houses. So I suggest we look at it from the point of project by project, because issues concerning buildings are different from issues concerning transport. So what you have to do is you need to get specific data for each project, just like how Omar mentioned. And that's what we are trying to do. We are open to get data from all sides. And once we get all the data, then we will look at how we will go about analyzing them. But to give you maybe a general answer, because cost management is something that I have done over the years, cost and risk management is the area that I studied. To give you a general answer, one of the ways to prevent cost errors and cost issues is, one of them is to use if you are going to forecast or predict cost, then you have to make sure that you have the right data, is one. Two, you have the right model so that you will not have prediction errors. So that's to give you a general answer. That's what I'll say. Thank you.
Okay, thank you. Thank you so much. Another one just also related to the same question. So you mentioned about reviewing each project individually and prepare the data or the documentation. Now, yes. What do you think? What type of project data will be required here?
Here, we need the cost information. The cost information is, for example, if you take the materials purchased. So each supplier, so let's say if you are in Sydney, currently there's Western Sydney International Airport, which is currently ongoing. It's expected to be opened somewhere September, October this year, Western Sydney International Airport. So with this project, for example, so there are different suppliers who have contributed to the building of the project. So if you really want to get to know the cost information, cost data, then you have to take the data from each of the suppliers who contributed. But I know that the project manager or the contractor, who is the main contractor, who is in charge of the Western Sydney International Airport, they have a cost team. They have a cost team, those who are in charge of their costs. So I guess they have all this information. So the best thing is that you need to reach out to the project management firm, and specifically the cost team. They will be able to give you the right information or the right data for the cost. That's for the cost. In terms of the materials, I'll say the same, because cost and material normally they go together. The materials here is about the quantities. So you can look at the quantities, or maybe if you go extreme, you can look at the bills of quantities. So you look at the bills of quantities, you look at the cost sheets. So these are where you can get them from. But the most important thing is reach out to each of the project managers, which in this case we are trying to do. We are reaching out to each of the project management organizations, as many as we can, and as many as they are ready to give their information to us, because we know it's very difficult. Most of them, they see this information to be more like confidential, private information which they don't share with the general public. So that's what we are doing. We are trying our best.
Jim, totally understand. I just wanted to understand how this will be done with this AI now. Yeah. Thank you.
Okay.
Thank you so much.
Thank you so much.
Thank you, Isaac, and everyone for the question. Really interesting. Now we're going with Franklin.
Okay. Going to turn on my. All right. I'll be sharing my screen. Okay. So today, by the way, my name is Franklin Nwosu. I'm from Nigeria, and today I'll be discussing about new development in AI forward instant quoting for small construction businesses. So because of time, I would be try to rush it a little bit. So sorry about that in advance. So introduction here. Welcome to this webinar presentation on the latest development in AI powered instant quoting for small construction businesses. Today, this section explores how artificial intelligence is reshaping the construction industry by improving cost estimation, reducing delays, and helping small businesses remain competitive. So here's the background of the project, and first of all, the problem of the project. Small construction businesses often face challenges such as slow manual quotation processes, inaccurate project cost estimates, human error in calculations, delayed response to clients, difficulty competing with larger firm using advanced software. So in this, what it entails is that for me, in my personal experience in furniture and carpentry, one of the major problems I've noticed that we face is giving like an accurate quoting to customers, because most of the time these customers, when they come to your company to produce like let's say a bed, wardrobes for the rooms, they don't give only your company the task to provide the quotes for them. They go to various other companies that are into the same furniture to provide a quote for them. So providing like a quote as fast as like in minutes, or within minutes or an hour, depending on the project, will give you like a more upper hand against other competitors in providing this quote. So why are we doing this research? Accurate and fast quoting is critical in winning contracts, like I said, and maintaining customer trust. AI provides an opportunity to automate and improve these processes. So next, our aim of research. Our aim of research here, our research goal is to innovate how artificial intelligence can be used to create instant and accurate quoting system that supports small construction businesses. And here is our key objectives: reduce quotation preparation time, improve cost estimation accuracy, increase operational efficiency, support decision-making in construction projects, and create affordable AI solutions for SMEs, that's small-scale businesses. What is AI-powered instant quoting? AI-powered instant quoting uses machine learning algorithm and historical project data to automatically generate construction estimates in real time. Here is how it works. User inputs that project details, AI analyzes project requirements, system prepares historical data and pricing, instant quote is generated, quote can be adjusted and sent to client immediately, like I explained earlier. Like the faster you reply your client with your quote, the more chances you have in getting the project. That's based on my own personal experience. Here is the most recent development for this project is the emerging technologies. Machine learning based cost prediction, AI-powered takeoff software, real-time material price integration, just like Mr. Isaac is saying. This is like a major issue that I predict that we might foresee in this research and project. So, like I believe with good planning and integration with the suppliers and some of the construction workers, like some of the construction companies, the small construction companies, with the collaboration, I think we can see this like working. And also, cloud-based estimating system and predictive analytics for project risk. So here's the industry trend. Construction firms are increasingly adopting automation tools, smart project management system, AI-driven scheduling and budgeting, digital transformation strategies. Okay? The new development in this project are, here is the current progress. The project has recently advanced into the development of a conceptual AI quoting framework. Like we have already developed a framework on how we're going to achieve this project. and questionnaire and survey design for construction SMEs. We have already created a questionnaire survey, which we have sent to some of the SMEs that we can find, and we've already gotten some response from them as well. And the next one is identification of AI models suitable for construction estimation. Just like Mr. Said, Mr. Matt said about using API, like to get as a model for us to achieve this, the pricing and the pricing cost of the materials. So the case study, the next one is case study preparation involving small construction firms. Then the proposed system focuses specifically on small business affordability, ease of use, fast response to client, reduction of manual calculations. The benefit of this benefits to small construction businesses, the key benefits are faster quotes, improved accuracy, better customer experience, increased competitiveness. Like the small scale construction businesses will give them a chance to compete with the big construction businesses. Just with this small software that we might be able to create, this is going to help their competitiveness, not so that the margin will not be that broad. So, and also cost saving for the small construction businesses. Next is data collection method. Our research methodology update here is data collection method. The project currently uses survey and questionnaires, interview with construction professionals, literature review, and comparative analysis of existing AI systems. Target participants are the small construction business owners, project managers, and construction technology experts. The next one is our current challenge is limited awareness of AI among the SMEs. Like most of the companies, small scale companies, they don't really know about this AI, and most of them don't know how big it might be for them, and how it might really actually help them in competing with the bigger firms. So the next one is cost of software adaptation and data quality and availability. This is really the major part we need to focus on, getting really quality data and availability for the software to be able to make it much easier for small construction businesses to assess and give an accurate quote to the client, because it doesn't make sense. It really damages a reputation for construction businesses whereby they send a client a quote after the project is being approved, then they find out that the cost, either the cost of the project is lower than expected, or it's higher than expected. Then they have to go back to the client and start to request for a new fund for the project, which is going to really strain the relationship between the client and the client and the small scale business. So the next one is resistance to technology change, need for employee training. So with this software, and we're going to make it much easier for companies to use, but still their employees are going, we might have to undergo a small training so that they can find the best way and the easiest way to use this software. So here is our proposed solution to these challenges. We're going to make affordable subscription models for this software, user-friendly interfaces, and AI training workshop, cloud-based accessibility. Our preliminary findings are early observations are research findings suggest that most SMEs still rely on manual estimation. These are like observations that we found from our questionnaires. Businesses want faster quotation system. Many firms are interested in AI solution if affordable. Accuracy and simplicity are a major concern from this survey. The industry readiness. The construction sector is gradually becoming more open to digital transformation. Future development plan. Here is our plan that we are hoping to execute in a few months or few years to come. Is to develop AI prototype system, conduct pilot testing with selected firm, evaluate system performance, improve prediction accuracy, expand integration with project management software. And here is our long-term vision: to create a practical AI-powered estimating platform for small construction business globally, not just in a specific country. We hope to go global, whereby even smaller countries will be able to access this software and still get an accurate quoting for their clients. I know it's very hard, but it's something that I believe that we'll be able to achieve with time. Expected impact. Business impact. These are the impact that the business are going to gain from this project: is increased efficiency, improved profitability, faster project approvals, better resource management. The educational impact is ICONSMAT can become a leader in this project. Like with them, I believe we can achieve this project and really actualize it in becoming a real-time thing. The ICONSMAT can lead in the AI construction training, digital construction innovation, industry-focused research. So here's my conclusion for the presentation. In summary, artificial intelligence is transforming construction estimating and quoting processes. This research demonstrates how AI-powered instant quoting system can help small construction businesses improve efficiency, cost reduction, and remain competitive in a rapid changing industry. And here is my final message: the future of construction is digital, and AI-powered quoting represents a major step forward, smarter and more efficient construction management. And thank you for attending this webinar. I'm open to question if you have any.
Thank you so much, Franklin. Really interesting topic. Does anybody has a question for Franklin? Matt. Oh.
Can you hear me?
Yes, we can.
Yeah.
There's a couple questions. Just this might be the most difficult one. Is that, have you selected a Agentic AI or an AI system yet?
No, we haven't reached that part, but I hope that's why I said I'm willing to collaborate with Mr. Isaac in achieving this goal.
Okay. Because you're going to have a bit of a flood in the market. There's about $30 billion of investment capital in the last couple of years into really digital. And it's just causing many choices among the AI. And therefore, we know that the AI community will collapse to something less. And if you have a subscription to one of these upstart companies that's very sincere, very aggressive, but they end up going bankrupt, you really, suffer their cold, right? You've got the flu now because you have to change over. So there's a bit of a methodology there. That'll be a little tough as far as picking that solid foundation you can run with for 10, 20, 30 years as you build your business. The other part is that I posted this little graph over here. We've been watching it, but we have the highest adoption rate of AI as a construction industry, other than the other three goods producing industries, fishing, forestry, agriculture, and mining, and all these. So we're pretty advanced as far as an industry, although we're very self-critical. It'll be interesting. Let me ask the last question here, just to give you direction. There's the construction bankruptcy is the highest risk in all factors that are contributing to construction bankruptcy is in work acquisition. What you're proposing, right? So contractors know that, right? We can't take a price back that's an error, and if we're too high, we'll never get a phone call back. So we have to be highly accurate. And so there'll be a bit of resistance there, I think. You'll tell me, or you'll tell us next year how it's going, but I suspect that will be a bit of a barrier. Have you? This is a good comparison if you're going to do the research. Is if you take an Excel template and just super program it, which has been done by people, and then you take AI, you can see where the contractor is going to trust one over the other. This one is obviously very malleable to the manufacturers who might be supplying prices or some sort of labor coefficients and sorting and things like that. This one is really new, inventive stuff that's subject to errors and mistakes and eventually mistrust if there's a lot of errors and mistakes. I don't know if you've looked at that as far as a contractors and his risk management, saying, well, maybe a little more Excel and a little less AI, because I don't know that much about AI.
Yeah, this is a very good question, which, like I said, it's a real-time problem that we are facing. But I believe that in every problem, there is always a solution. And also, something about trust is something that you can always build. You understand? And with this research, I believe that there is a way we can gain trust of the small construction businesses by, like, before we put the software to the public for use, we have to go through thorough testing. At least we have to select a few construction businesses, like just very few, and test run the software before going into public. And we're going to focus more on accurate data, getting an accurate, which is very difficult, but I believe that we can do it, because now in this world, I think most of the thing, I think AI does most of the thing for us. Like in the near future, I think most of the people are going to be using AI and find it much easier than going back to manual. Though people believe in manual because they know, okay, they have done this, it has been existing for a couple of years, and now going to trust AI is going to be a little bit complicated. But it's a gradual process of building a trust for the companies with this software. But I still believe, hopefully, we are going to create something that it's worth a while and can withstand any competition.
Well, let me add one more thing. It's just a thought that occurred to me, and I've looked at this hard like you have. Maybe you've looked at it harder than me, but if you start as an estimating service, you and others, 3 or 4 of you or just yourself, and you say we're an estimating service for contractors and we'll produce, bills of quantities with pricing. If they give us the pricing, then you're really starting to build your credibility with people because you actually have accurate quantity takeoffs. And again, maybe pricing's included because they give you the pricing, or maybe you do something else. But from that perspective, that's a really quick pickup versus you say, well, trust me. Of course, you can estimate any job that you come across, whether it's at some common builders exchange. I'm not sure what the process is in your location, but you just go in there and there's 12 contractors bidding it, and you give them a bill of quantities unsolicited and say this is what we have, and it's very accurate, and they start paying attention to you, obviously, because after about the third, fourth time, they say, boy, whatever you're doing is very accurate, and we'd like to talk to you further. Yeah, that's it.
Thank you very much for that advice. Any more questions?
Oh, I just probably have something very minor to add, is that based on my understanding and my experience, the main reason why the construction world do not trust AI is because of the privacy and the security of AI. So my suggestion would be try to probably stay away from a cloud-based AI model, and I guess it will be more marketable, if we can use that word, to other people. That would just be my feedback. Thank you.
Okay, thank you very much. So why we are using the cloud-based AI model is because to have history of the works done, whereby when the software is making an analytical like survey or analytical price quoting for any client, it will be able to get an accurate based on the past and the future projects that's been done. Because without the cloud-based like model, we won't be able to get to compare like the past and the future analysis. So, and also we are going to make it like the companies that are willing to provide their data of the work they've done and everything is going to be private. Like, it doesn't list the company's name or anything. It's going to be private. Only the AI have access to this cloud base, not just the other competitors of that particular company. You understand? So if you're using cloud base, it's going to be AI that has the access to it and to give an accurate quotation.
Yep. Thank you.
Any more questions?
All right. Thank you so much for the question, Franklin. Thanks again. Now we are going to continue with Timothy.
Good morning.
Hello.
Yeah, good morning.
We can hear you.
Yeah, can you hear me?
Yes.
Yeah, good morning. Good morning from Nigeria.
Good afternoon. Good morning. Here. Yeah.
Okay. Okay, let me share my screen. Okay, I am a civil engineer from the Federal University of Technology, Owerri. And my research proposal is on evaluation of the efficiency and effectiveness of conveyor belt systems in construction material handling operations. Can you hear me?
Yes, we can, but the
Hello?
screen is not full. Yeah.
Okay, let me. Wow. But I've shared my screen. Can't you see it?
Yes, we can.
Okay. Let me start with the introduction. Conveyor belts are widely used in Australian off-site construction, especially in asphalt plants, that's asphalt mixing plants, batching plants, and crushers. Even though we have on-site machines that also make use of the conveyor belts, like the asphalt scrapers, which makes use of the conveyor belts to transport the asphalt, the scraped asphalt, into trucks for either cutaway or so we have the EP conveyor belts, which dominate the construction and quarry operations due to their flexibility and resistance to impact and moisture. Efficiency is defined by throughput, which is the ton per hour. Energy consumption, downtime frequency, maintenance cost, belt utilization rate, and operational reliability. Conveyor belt components, that's the tackers, cover rubber, pulleys, idlers, rollers, drive units, all influence operational durability. Then these are the research questions. The research questions, research question number 1. What conveyor belt components and operational factors influence system performance in asphalt plants, concrete batching plants, and crushers or quarry plants? And then the research question 2, what are the most common operational and mechanical failure modes affecting conveyor belt reliability in construction manufacturing plants? Research question number 3. Sorry, research question number 3. How efficient are conveyor belt systems in terms of throughput capacity, downtime reduction, energy consumption, maintenance cost, and operational continuity? Research question number 4. What are the economic implications of conveyor belt operational failures? That is, when you have failures, the economic or cost implications. Because failures, when you have failures, it costs you more money. So downtime reduction, when you have failures, you have reduction in downtime. You have energy consumption, maintenance cost, and operational continuity. Research question number 4. What are the economic implications of conveyor belt operational failures in off-site construction as manufacturing plants? Research question number 5. What strategies can reduce operational failures and improve conveyor belt efficiency in asphalt plants, concrete batching plants, and crushers? And then we now go over to the literature review. For the literature review, for the literature review, we have what the research shows. That is the former research, the ones that have been done, show that conveyor belts reduce handling time and labor costs. Conveyor belts, because they transport materials faster, they help in reducing the time that is required in handling, unlike the conventional methods of handling, usage of trucks and manual labor. They enhance workflow continuity and operational efficiency. They improve site safety by minimizing human interaction with heavy materials. Thus, they reduce the rate at which you interact with the materials, because it's now the machines that move the materials, not you, that is the human being. Energy efficiency is a key concern in raw material industry. Offsite construction scales and technology are evolving in Australia. Then we have research gaps to be identified. The research gaps to be identified include limited integration of primary and experimental data for evaluating performance efficiency. 2, no specific focus on Australian offsite construction plants. That's the asphalt, batching, and crushers. Insufficient comparative analysis, that is against the traditional handling methods. Few studies combine quantitative, which is time, cost, and productivity, and qualitative. Qualitative is user perception. Then research methodology. We have the research design. Quantitative approach, measuring time savings, cost reduction, and productivity rates relative to inputs employed. Sampling, purpose selection of construction sites with active conveyor. That's the sites to be sampled. Purposive selection of construction sites with active conveyor belt systems and long-standing operational experience. Population, that's the research population. Asphalt plant operators, concrete batching plant operators, and crusher machine operators. Data analysis. We have the descriptive statistics using mean, standard deviation, and inferential tools, including regression analysis using SPSS and Stata. SPSS/Stata. Then data collection. We have the primary, which is structured questionnaires with construction professionals. And then the secondary data collection. We have project reports and site reports from selected firms. Validity and reliability. Pilot testing of instruments. Chrombatch alpha for internal consistency. Cross-validation using plant data and survey responses. The next page is for system performance analysis. And we have SP, you have the formula there. Then these are the indices. You have roller and idler condition. You have motor power, tongue, and speed performance. Torque, motor power, torque, and speed performance. Pulley and belt alignment. Belt condition, that is the condition of the belt, because it's affected by wear, tension, and slippage. Conveyor, loading site, and capacity utilization. Belt speed optimization, that's the speed of the optimization speed of the belt, sorry. Automation and sensor systems. Monitoring and control systems. Material characteristics, which includes particle size, moisture content, abrasiveness. Environmental conditions, like the temperature, dust, humidity, these also affect it. They affect system performance. You have structural integrity of frames and supports. Preventive maintenance practices. Operator competence and maintenance response time. energy consumption characteristics. And then we go over to formula and variable key, that's SPAM. We have roller and idler condition, which is RC. That is from the, you have the formula there. SP is equal to F into RC, MP, AL, BC, BS, CU, AS, MC, MT, EC. These are variables. Then we go over to the next page where we have analytical models. ROQ2, that is research question 2 to research question 5. Failure mode and reliability analysis model. The conveyor belt operational efficiency model. Cost of operational failure model. Operational efficiency improvement and optimization model. And you have their formulas there too. Then it's a 12-month research. The timeline is 12 months. For the first quarter, which is the 1 month to 4 months, we have the proposal refinement and supervisor engagement. We have extensive literature review, research design finalization, and pilot study. And then for the second quarter, which is months 5 to 8, we have data collection, field work and surveys, and then data analysis and interpretation. For the third quarter, which is 9 to 12 months, we have drafting of thesis chapters, review and revisions, and final submission and defense. Expected research outcomes. These are the outcomes we expect to have at the end of the research program. We have quantified the efficiency of conveyor belt systems in construction material handling. That is, we should be able to quantify the efficiency of the conveyor belt systems as against the traditional methods. Question number 2. Number 2. Compare performance between the conveyor belt system and traditional handling methods. That is, at the end, we should be able to compare the two and take decisions. I believe the conveyor belt method is, it gives you more output, it saves you cost at the end of the day, and also it reduces your interaction with materials, that is human risk. 3, identify operational challenges affecting system effectiveness. 4, provide practical recommendations for improving material handling processes. Number 5, contribute to academic literature addressing gaps in developing country context. Like in developing countries like Nigeria, I think we have some other factors which make the use of conveyor belts a little more difficult for us, like in places where you need power, because we don't have constant power. So that means you have to, most times you make use of gas to power your machines. And it is more expensive to run, even though in the long run it might be cheaper. But it is more expensive because you don't want to, you want to avoid downtime. You want to avoid producing at the middle of a production cycle, you have a breakdown. because there's no power. And then you start looking for alternatives. So these are things we consider. Then deliver findings valuable to construction firms, policymakers, and researchers. Conclusion. This research addresses a critical knowledge gap by systematically evaluating the performance efficiency of conveyor belt systems in the Australian off-site construction, specifically across asphalt plants, concrete batching plants, and crushing or quarry plants. Using 5 analytical models and a robust quantitative methodology, the study will generate actionable insights for the construction industry, informing policy, practice, and academic discourse. Thank you.
Thank you, Timothy, for your presentation. Does somebody has any question for Timothy?
Can I just add a bit of a suggestion, if I may? The 4 models you've presented, Timothy, are pretty amazing, those equations. Just last week, I was talking to one of our colleagues from Germany. There was a recent development on something called AI-powered preventative maintenance for conveyor belts. That was a camera that was put on the end of a conveyor belt, and it would be able to predict whether the belt is going to tilt to one side and start spilling materials, or if there is any cracks about to initiate. Just to add a bit of advancement to what you're currently doing as part of improving efficiency for conveyor belts, those systems are also effective. That's all I wanted to say.
Okay. Thank you. Yeah, you're right. I believe most times it is cheaper for you to do preventive maintenance than to allow for a breakdown first.
Yeah, that's right. That's right.
Yes. Yes, there was something you also posted about the scrapers that reduce the carryback. Can you? I don't know if it was you that posted it. I think so. That reduces the carryback on conveyor belts. It kind of scrapes the belts, reducing the quantity of material that goes back. That is, especially the materials that will stick to the belt.
Yeah, these are all kind of practices that can help maintain a belt.
Yes, these are, yes. And then probably lubrication and all that. There are a lot of them that you can do. And also once in a while, maybe when you shut down, you can also do some of those maintenance works to avoid breaking down maybe at the middle of production.
Thank you.
Thank you.
Thank you so much. Now we are going to return with Tahera, yeah, because she has some problems with the internet. So now she's going back to finish her presentation.
My bad. Out of all the time, there was a glitch in the internet while I was presenting. Really sorry for that. It wasn't in my hands. So anyways, I'll just quickly share the screen and I'll try to convey what I had prepared. Yes. So with a quick glimpse, yes, I had utilized Bagasse fibers and Bagasse ash together. This was one of the novelty. Though there are many previous studies that was done incorporating this in concrete and mud blocks together, this was one of the first kind. And we had done the tests on materials to check for the permissible limits and tests on blocks. And we tried to take this to the factories and come out with the product, how exactly it could simulate the real-time situation. And a simple quantification helped us to know how much was the reduction in carbon emissions. So there is a simple life cycle assessment and a decentralized production ecosystem, wherein definitely it is going to help in providing 25% of the social equity. And when it comes to this feasibility, we had compared all the materials put together with the market available product. So at Bengaluru, a similar mud block is costing 55 rupees, and it actually ranges from 40 to 55. And with all the materials that we had come out with, we were able to produce the same strength, same quality with 33 rupees itself. So there is, even if we can scale up to a small construction G+1 floor house with a simple 2-bedroom house, and if we can quantify the number of blocks that is required, the profit is also somewhere around 40 to 50,000 rupees for each project. And we also did comparison with respect to concrete blocks, fired clay bricks, and the conventional compressed block and our Bagasi block. So with respect to the energy use, emissions, strength, it was satisfying all the requirements. And when it comes to cost, it was reduced, and even technically it was sound. If we have to set up a production unit, this was the tentative cost estimate that we had done with respect to human resources, technological resources, infrastructure, block production, and any other miscellaneous costs. So major investment lied in the automatic machine that is required for preparing the mud block. So that was a huge investment that we'll have to put in, because materials, we don't have any problem, resources is fine, and even the manpower is also fine. So it comes out to like 8 to 10 lakhs for having one production unit, excluding the transportation and things like that. We also try to approach certain research funding agencies. So Indian government is giving so many opportunities wherein we can do, wherein they fund us to give more opportunities to do research. And also we have Pradhan Mantri Awas Yojana. It's a scheme wherein they fund for any startups. So we have even tried to approach them. We are on the way, and my project will satisfy sustainable development goals 9, 11, 12, 13, 8, 15. So there was emphasis given on the sustainability development goals as well. And yes, we have with the pilot studies that we have done, we have published a patent, sustainable mud blocks using Bagasi. We are still trying to implement AI machine learning applications. As a civil engineer faculty and with structural engineering background, AI is something new to me. I'm still in the basic understanding level. So I'm still collaborating with experts who are already in the field of AI, and definitely I'm open to collaborate. So basically, what I understood about AI is it requires data. So we require more samples so that we can feed in the data into it. And I'm still working out in finding out ML models such as random forest and the gradient boosting, cat boost, LG boost, and models like that. And I have understood that there are certain neural networks, ANN, FNN, all these LLMs and things like that. So I'm collaborating, trying to find out how I can give the input features input features that I have obtained from the laboratory test, so that it can give me the prediction of compression strength or whatever the output that AI can give me. So this will definitely reduce the extensive laboratory tests that I can do with the basic information and understanding that the machine can learn from. So I'm still working on it and trying to have a research paper integrated with AI for this project. And coming to the conclusion, yes, with the laboratory studies, what we have done so far, there is a reduction in 30 to 45% of carbon, and almost 1 to 2 tons of agricultural waste is utilized in the blocks, and 25 to 30% of cost reduction is seen, and compressive strength is as per the codal provisions. And yes, we have even contacted one of the startup agencies wherein we can pitch in this idea. So yes, there is progress in many ways. We are trying to collaborate, and these are the few references for the previous studies. And yes, I would like to thank by quoting a quote, plan or perish or industrialize or perish. This was a quote from Sir M. Vishweswaraya. He is considered as a father of Indian economic planning. So he has contributed so much in the field of civil engineering to the modern India. So yes, I'm open to any questions on this.
Tahera, it was a really good presentation. Please let us know if you have any question for Tahera.
Sorry, just a quick one. Thank you again, Tahera. What's the final product? Is it brick or is it the supplementary powder Dutch?
The final product is a mud block, a compressed, stabilized mud block. Yes.
Is it ready for import or export?
Yes, definitely. If I can get a chance, I would like to go on a large scale.
We'll see. Thank you.
I have a question, or maybe
has a question.
Yes.
Sorry, Hala can go. You can go first, and then I'll go second.
It's okay. Anyway, thank you so much. Tahera, while you are presenting the topic, there is a formula for estimating the carbon emission. Can you please just go to this slide?
Yes.
Yeah, for the emission factor, what the source for this?
The sources is basically a tentative values from the previous studies itself. So we can just from the literature survey, I have just gathered up for these materials how much could be the emission factors. And there is also one of the code book as per the Indian standards where I was able to take few values out of it.
So mostly from the literature.
Literature, and also there is one, yes.
Yeah, do you have the name of this book?
I'll definitely look into it and I'll just give you.
Okay, thank you. That's all from my end. If you can just later on type it in the Zoom chat. Yeah.
Yes, definitely.
I don't have a question, rather than just a note to add to it for marketing value. Have you looked into the insulation of this new block and how it's efficient in climate controlling of any building?
Yes, my studies was just limited to the initial laboratory tests, but definitely I'm looking forward and I'm working on long-term tests as well, with respect to durability, and also AI models as well. And recently, I have given the optimum mixes to undergo SEM and XRD tests as well, so that I can get to know the chemical composition and also how the microstructure of that material is. So yes, the study is still under progress.
Okay, thank you.
Thank you so much. So now, just a sec. I would like to say thank you to everyone. We already finished our webinar. It was a pleasure to meet all of you. Really interesting topic, so we really appreciate it. And yeah, looking forward for the next one. Please stay connected through our website, webinars, and social media. Thank you so much.
Thank you.
Thank
Thank
you.
you. Thanks.
Valeria.
Bye, everyone.
Thank you,
Bye.
Valeria. Thank you.
Bye. Have a nice day.
Thank you very
Bye-bye.
much. Bye bye, everyone. Thank you.
Thank you.